Let me give you an analogy. And I already have the idea in my mind. Existence must be necessary to the idea.
Advanced simplicity takes hold. You'll find the truth from things of old.
I have an idea in my mind. I have an idea in my mind that a triangle exists. The idea in my mind. But the angles of a triangle do not add up to 180 degrees. Think about it. I have an idea in my mind that a triangle exists. But the angles of a triangle do not add up to 180 degrees. What's the conclusion?
We are on the road, suspending judgment until the truth is known.
Think about it.
You will find peace within, in the midst of all these troubled souls.
I have an idea in my mind. What's the conclusion? You don't know what a triangle is. Or you're flat out contradicting yourself.
Advanced simplicity takes hold.
You're flat out contradicting
You'll
yourself.
find the truth from things of old.
You don't know what a triangle is. Or you're flat out contradicting yourself. Just as it is necessary for a triangle to have 180 degrees. What's the conclusion? You don't know what a triangle is. Or you're flat out contradicting yourself. Think about it. It is necessary for a triangle to have 180 degrees. That is a necessary property of triangularity, triangleness.
We are on the road, suspending judgment until the truth is known.
Think about it.
You will find peace within, in the midst of all these troubled souls.
Therefore, the fool is in a self-contradiction. He violates the principle of non-contradiction.
There's no end game in mind.
Therefore, the fool
It's only the truth that we seek to find.
violates the principle of non-contradiction.
There's no end game in mind.
The fool,
It's only the truth that we seek to find.
therefore, the fool is in a self-contradiction. He violates the principle of non-contradiction. He simultaneously says, I have an idea of God, and then I don't have an idea of God.
Everyone must see it for himself. The truth is there for you to find.
Think about it.
And we are live. Welcome, everyone. Few of you. Good day. This is dedicated to the proofless logician, Buddy. He has he's requested that we go over. I call it the transitive law of equality. That's what I've always been told it was. It's got many different names. Some people don't like to call it a law. Some people just like a property. There's all sorts of different names that people use for this. But it's just if things are equal to the same thing, let me get me Euclid. This on the axioms. Axiom number 1. Things which are equal to the same thing are equal to one another. I think that says it a little bit simpler. But it can be said, if A equals B and B equals C, then A equals C. More of an algebraic one. I prefer the Euclid. Things are equal to the same thing, then they are equal to one another.
They are the same thing, but this example with letters, this is example. So this is application. How it works.
Yeah,
Example.
I think what a lot of people are getting an idea of is that all of these three things need to be the same, but it's not. This isn't quite like that, right? They're equal to the same thing.
Yes, same but different from the previous one. So we have three things here, and we are comparing two things to third thing, and this third thing is the same thing in this sentence.
Yes. Yeah, and that's the transitive law, because you get to make a conclusion by equating that you're saying that they're equal to the same thing in a way, so they're equal to each other. In basically, Betty's asked that. Let me get this. I don't know. I can't remember what he called it. So, seeing as Betty's requested this, I best check that we're getting the right thing for Betty, because no doubt he's gonna go over this, and he does reviews, and he documents all of this sort of stuff. He timestamps it. He tells Blue Marble all of these different points. So get ready. Blue Marble started doing it as well, actually. There's one here about paper. I'll go over that, right? So this says, just one thing for you to discuss tonight. In fact, I'll get it and put it in the chat so you guys can see it. I can't talk and so okay, this is for Betty, in honor of him making up arguments over there at Blue Marble Science server, and because obviously he gave us the some way to disprove a globe, I think. But anyway, he says, just one thing for you to discuss tonight. The law of transitivity. So I hope it's the same thing. I mean, it says also known as the transitive property of implication. States that if A is equal to B and B is equal to C, then A is equal to C. Do you agree with that law? Yes or no? I replied to him, I've made an argument around that quite a bit ago to Blue Marble, which we will be going over tonight, right? Just in honor of Betty, because in case you thought I was lying about it. No, I mean, it's one of the most basic axioms. It's axiom 1 in Euclid. So that's one of the, I'd say, the first laws. If you were going to make an argument, that should really be your starting point, because it's the simplest thing to explain to anybody, right? It's the most basic logical statement that you could ever make.
For me, this is just the law of identity. So I don't know why this is called, or Bebby is calling that law of transitivity, or transitive property of implication. Property is not a law. Property is property.
I know, but there's a lot of that, you know, if you look into this, new modern science and I don't know, logic or whatever, has obviously had to change laws, because What, with dilithiism? Like, I mean, they can't really say it's a law. They're not allowed, are they? If you're going to have drop a little dilithiism axiom, right? You can't go around brazenly stating laws and things like that.
I have formal objection to what he said, because he is equivocating the law of transitivity with transitive property of implication. So he is equivocating law with property. And this is my objection, because law is not property, but he is equivocating that. I object.
There you go, Betty.
Property is, for example, that cat is white. So he has this property, that whiteness or blackness or whatever color you pick up. So, and this is not law. Property is not a law. Sorry.
And it seems like you may be getting under Blue Marble's collar a little bit, Paper, because look at this. This is all for you. Look at that. Blue Marble's writing you a book.
But he's using big E.
Yeah.
And
he's on your side.
And I don't know in which way he's using a word globe. If
it's only a little g.
Oh, I still don't know.
Yeah.
What he's talking about.
But you shouldn't you? Because I mean, I've heard that a lot, right? You're just feigning ignorance that you don't know what Blue Marble's talking about, because he's obviously wrote quite a lot of words there. And I bet Betty understands what he's talking about. I bet there's a few people over there at the Blue Marble Science HQ letting us know. But anyway, that's by the by. We're going to go back to the transitive law of equality. Did I have... I don't know whether I actually had it on here or not. Oh, there you go. This is the one that I've been using. I can't quite get that in. So let me click that off. Move the screen back. Okay, so this is one that I did a fair bit back, and it was similar. I mean, a lot of people, this is the sort of, once you first start to formulate logic, I think these are the most simple type of logical processes that you can do, where you relate two things together and then come to a conclusion. Well, obviously, we've got this argument, right? You equate two things to a similar thing, and if in this case, an equal elevation.
Yes, because in that statement, if A equals B and B equals C, therefore A equals C. Of course, in this example, we are not talking about letters, because A is not B and B is not C and A is not C. So we are talking about similarity in within the thing. So in which regard they are the same. For example, if we are talking about color, then we can say that three different things are equal in regard of color or shape or whatever else. But of course, there is no such thing as same things being different and same, the same individual. So you cannot have three different individuals being the same thing, the same substance. So this law is talking about, yes, property shared by three, let's say, objects. So if they share the same color or shape, we can say that they are equal or the same in regard of color or shape. This is what Euclid is talking about. So in which regard it is equal or the same? So if we have two straight lines, so they in different position, let's say, or in different location, better to say, they are equal not because of their localization, but they are equal because they are both straight. So they share straightness, both. So they are equal in regard of their straightness only.
No, in the idea of this is that level is an equal elevation, right?
Yeah.
That's the way it is, and as is horizontal.
Yeah. So they share. Yes.
So they share a similar property being an equal elevation. They are equal in the regards that they share the property of having an equal elevation, and also both of them are perpendicular to plumb or vertical. Same thing.
Yes,
Another
so
property that they share similarly.
Two properties, yeah.
And probably many others, right? But for the sake of a meme and an argument, I don't think you really need to. You don't really need to have two. You just want either of them will do. To state in that regard, with them being equal with that property, then they are equal in the sense that they have an equal property shared.
Yes, yes. So it means that they have this inside themselves, this property. So horizontal is equal elevation and level is equal elevation. So they both share the same property. So they are the same in that regard.
Right, now, this, what we're going to watch here now, let me get you in for you guys. I don't want to be wasting any time. I'm going to try and get into the... this is what I titled The Debate. And it is perhaps one of my most viewed videos. It's got 3,500 views, which for my channel is very good. I have to thank Dave Weiss for that, because I think he's done that. But listen to how I did at the beginning formulating this sort of stuff, and when I hear this back, I keep hearing myself going and it's obviously a fair bit ago, but let me just put this over here. Okay, right, are you guys in Discord? Yeah.
Yes, we are on track.
Yeah, that's muted.
Yeah, that worked. All right.
Okay. So are you okay for me to
yeah,
with
I'll
my
go on
opening?
mute. I will go on mute, and it's all yours.
Okay. Welcome everybody. This is the debate done over on the Level Discord server. As we've said, requested by Blue Marble Science. I thank you for giving me the chance to be able to do this. I'm going to treat this as a sort of a dissertation type thing of an end of the study of what we do here. Now, what we do here is called, well, we've named it Advanced Simplicity. What we do is we find a topic or whatever and we break it down to the most simple that we can. Now, as we do that, we have done it with geometry because of the initiation into this arena that we had was through geometry. It stuck with geometry, but along with that came to the breakdown of the geometry, which led to logic, and then the breakdown of the logic into words. So that led us to the trivium. Now, the trivium is a way to sort of a tool of learning how you process and how the mind works and how you link things together through the identity of subjects and through to the logic form, and then down to finally the rhetoric of how that's portrayed. That's what I'm going to aim to do today, is to give you a chance to have an insight into what we're doing here and what the way this works. So this debate is an idea where you present an argument. Now, an argument, I think a lot of the time, back to words and all of that, has been taken over. It's now come to mean people shouting at each other, maybe body parts being dangled, and you know, other acts that seem a bit strange. But in reality, the argument is a form of sentences that are put together in a way to make the mind do a little bit of work and for you to be able to come to a conclusion. So within what we're doing here tonight, I'm going to attempt to break down and give you an idea of a couple of arguments that I've made in order to deal with Blue Marble. Like Blue Marble wanted the debate, Blue Marble Science wanted the debate about level is horizontal, level is quest ... and all horizontals are ... So I'll give you a chance to try and do that. Let me see, is my camera on there? Or wait 1 minute for you guys. I believe I had to reset. See, I was doing this live.
Now you're good, man.
You can see that now. So
yep.
If I put the whiteboard on, can you see the whiteboard? Okay, are you okay with that? Everybody on that? You guys on YouTube can obviously see it as well. Yeah. Okay. So initially at first, I guess you guys have seen this. If you say A equals B and B equals C, then you can say that A equals C. You see that? Right now, let me just move this microphone over it. Right, so you can see that these two and these two make this one as a conclusion, right? But what you can say is that this one and this one, that both this and this are the same as this, B. So these two have a common part here. And because both of these have this common part, then you can say that this one equals this one. It's called the transitive law of equality, but it's maybe a little bit confusing, a silly name, but I mean, this statement here is a basic understanding of a fundamental really of logic and reasoning, and you could say that this is also part of a mathematical understanding through logic.
Bill, I hate to do this to you, but
What?
how can I'm not able to see your screen.
So you notice here that this is in the middle of the debate, and Blue's got a video done, and he's interrupting. So this is going to go on for a bit. But what do you think about that? Like, maybe everyone all right with that? Yeah, along with it, haven't not made any mistakes or anything. Mainly, this is because Beddy's requested this, and just me to show him that I've done this in a debate with Blue already.
And it means that B is middle term. So this is this predication. So A is B or equals B. So A is subject and B is predication. In second sentence, B is subject and C is predication. But you can say that you can invert that. So you can say that C equals B. A equals B and C equals B. Then you have you can say that we have same predication. And of course,
you can see it as a middle term as well that you can get rid of.
Yes,
isn't
yes,
it? You know,
because
like
this is syllogism. This is syllogism. If A is B and if C is B, therefore A is C. This is like syllogism works.
Yeah. Okay, so that's good. I'll carry it on. Let you hear exactly how it works when you're having a debate. This is called a debate. I've gone first. This is Blues now.
Green.
In the Discord, I'm showing my camera.
It's live on his show, Blue.
Yeah.
Can you not see? The guys in Discord can see my camera, can you?
Just go to his. You just have to go to his channel.
We can see that on Discord. Just click Bev icon.
I think they can see
and
it, really.
click on that.
They're just doing it to
if you go to honestly. Agents of the Logos,
we know the
multiple icons will show, and click on Bev. So you will see.
Well, what I see is what it does is take me to the to your YouTube channel.
Yeah, he's sharing his YouTube
know how
channel.
To watch somebody's camera.
Yeah. Okay.
On Discord. Blue, it's
just
shocking.
give me a second. Then this is something we should have.
Yeah. In Discord, you click on his icon in the chat. You'll see it.
Yeah, I do that, and I click.
No, I mean not his icon on the camera. You know, if you go to
click on his camera,
like somebody leading Blue round like an old dude. Come on, Grandad.
That takes me to his YouTube channel.
Here. Wow.
Okay, so just hang on a second.
See that there, Grandad? Press that one.
See if I can figure out a way that I can share this.
Yeah, that one.
Because that's not how I thought I was going to be able to see it on Discord.
You can.
So just hang on one second. Let's see if I can change this window.
Remember, this is mid-debate, right? We just started. We started my bit. Luckily, I didn't get far into it.
Yeah. I'll tell you what I can do, I think.
He was searching in the wrong place.
Technical difficulties are always a problem.
Yeah, with you, Blue. No one else. Discord can actually see.
I can't.
If
It
you
might be because you're sharing your screen also.
Yeah, it might be.
So it's even
Okay,
worse.
I can do it
Mobius
this
helping
way.
him.
So I think now,
Oh no, Mobius has told me to do... I can't do that.
hopefully we've got
I'm
that
not
up
going to do that.
where everybody can see it. It just came on YouTube, so yeah, we're sharing it now. I'm sorry, Bev. I really apologize about that. Let me get back at. Start over again if you want to.
Okay, I'm all right.
We got it going now.
Yeah.
We're all good now.
Okay. Yeah, we can cut
So
that
from
out
the,
later. Don't worry.
The statement before, if A equals B and B equals C, then A equals C. We could see that there's a common part. So I'm calling this, I'm saying that the advanced simplicity that we're doing tonight is a lesson from Euclid. So this is Euclid's Elements, you can see on screen now. And the first axiom within Euclid's Elements states, things which are equal to the same thing are equal to one another. Now, you could say this is the foundations of geometry, the axioms that they go by. These are more common notations. They are in everything, really, within our understanding, within logic, within mathematics, within geometry, within numbers, within everything. It's things which are equal to the same thing are equal to each other. Now, that will be the form that I will be taking, well, both of the arguments tonight. To keep it as simple as possible, these arguments will be made around that very fact. So if that's how we break it down to simplicity, then what we're doing is we're taking the very first axiom of the fundamentals of the elements of geometry, which is the elements of mathematics, when you break it down to the logic form. So this is really the elements of logic that we're dealing with. And so that being the axiom, just get rid of that.
Okay, so the idea for me here is to, obviously this is a debate, the first chance we get to have a debate with Blue Marble scientists. And I think it's well worth pointing out how to form an argument first, to be able to explain how the argument is formed, so that Blue Marble could go along with it, right? He could get into the flow of exactly how an argument's formed. So that's all I've been doing on this part of the thing, is to, apart from getting interrupted by Blue, just to show how an argument's formed. Now I'm going to go and do the argument.
Here we go. So the first argument, I've replaced A with level, and C with horizontal. So all we have to do really within this form of argument is find a common element that both level and horizontal have in common. I would say equal
Why isn't
equal elevation.
sideways?
Now, I think everyone will be able to agree. Level is definitely an equal elevation. However, normal people would talk about that right now. Also, horizontal is, well, an auto level would produce a horizontal plane, and that horizontal plane would have an equal elevation. You would measure a difference. So the horizontal in that way would be an equal elevation, and level would be an equal elevation. So that one work. The equal elevation of a horizontal would be zero slope, no tilt either way. So therefore, horizontal is definitely an equal elevation, and level as well. So in order for you to make a nice logical statement like this, linking level and horizontal to an equal elevation is well, provable. I think this is something that's a natural thing. Everybody should know this. Very simple, ABC. So level is an equal elevation. Horizontal is also an equal elevation. Then for level is horizontal. Very simple. But again, I won't just do that. So let me go here, because I've been getting some going over this. Okay, so always argument first, form of argument first, and then back it up with as much stuff as you can. So here we go. Can you guys see that? Is that... Are you guys seeing that, or is it because
an
it's
ISO word?
ISO, yes.
Yeah, we're seeing it. It's
Okay.
clicking in and out, but we're seeing it.
I wish I could say it like SE when I come round to this. So ISO is a word for a contour line, and a contour line connects points of equal elevation. Like I just said, equal elevation. That's our nice connecting word. So a contour line or isoline connects points on a map that are of or equal value. Examples of contour lines or isolines are isobars or isotherms for pressure. Perhaps the prototypical example of a contour line is that which connects points of equal elevation. So here we have a contour line that is also an equal elevation. So it's another one to add to the group, but we're just talking about level, horizontal. But at the minute, we could put in equal elevation into it. And then there's a study here. This word is great. Isoipsi, I think, something like that. Isoipsi, ipsis. Something, I don't know. SE does it best. So, go on.
Iso ipsos.
Yeah, there you go. Listen to that. And that means equal height. So that's the word that we're dealing with. ISO means equal, and ipsi height. So I've got some more here. This one. This is a mathematical thing. It's a bit slightly off there, but so this is a contour line, also known as a level curve. For a given surface is the curve of an intersection with the surface of a horizontal plane. So a contour line is a connection of a line, a level curve, a point of equal elevation where it intersects a horizontal plane. So there's another link for the horizontal plane to the equal elevation. And then this is the mathematical graph to show you, how it works. I mean, everybody can see and knows what a contour line is, but the contour line is a line of equal elevation and where that intersects a horizontal plane. Horizontal plane, equal elevation, a line of equal elevation. There you go. There's another one, an example of the contour lines, and these are like horizontal slices depicting the okay, so through the put that back on. Through the linking of level, equal elevation, horizontal plane is also an equal elevation. You could say through this law that level is horizontal. I think I'll keep it quite simple. I mean, that's the basics of that particular argument, really. I mean, it's pretty simple and it's pretty self-contained within that, right? So that's level is horizontal sorted. Now, okay, does everyone think of that? Would you be confident in presenting that as an argument?
Yeah, of course. If level is equal elevation and horizontal is equal elevation, therefore level is horizontal. Simple.
Yeah, equal height, Stefan. That's exactly what we were saying. They're called contour lines on maps. And exactly what they show is a horizontal slice.
Good afternoon.
Good afternoon.
It's nice to see you on the whiteboard.
It's nice to what?
It's nice to see you on the whiteboard again.
No, that's old. That's from when I was doing the thing with Blue.
I know, but it's nice to see you on the whiteboard
Good,
again.
isn't it? Yeah, yeah.
It really hurts their feelings when you draw it out for them.
Well, I think, you know, as far as I was doing it, we like to have this approach, the advanced simplicity. Break it down, make it as simple as possible. Like, I probably could have presented it a bit better, could have had some better graphics and stuff, but for simplifying an argument and explaining how to do it, I think I did quite well. For Betty wanted me to go over it, so I think I've already done it. I don't think I could do much better than that, you know. I've got obviously I could write a meme up and probably make a little video about it, but it's pretty simple, isn't it? I don't think I'd change the argument. I think I'd keep the example of level and horizontal being an equal elevation. I don't know whether Betty's out there or if he's watching. He'll probably watch tomorrow morning. So that's one argument. And I don't know how much what time have we got? Yeah. Are you all right watching for another one, for hearing the other argument, for presentation? And then you might want to hear Blue's presentation as well, his video. That's interesting, especially at these times. So, yeah, we're going to continue, right? So I'm still presenting live here. Just given that one argument, now I'm going to go for another one. The other argument. We've been talking about this for quite a while. We went back over it for quite a bit ago. We've got all horizontals. We called this t-shirt logic because it was the first one that we ever did. The first logical statement that we ever did to be able to simplify a if-then statement because it was a bit popular a few years back, modus tollens, but modus tollens is an argument to the negative where you go over it. So you said it's not something, so we wanted to be more positive. So we we went with again Euclid in order to build the framework of the argument. We used Euclid to show us the way to build a well-framed argument. So this is the building blocks of another argument, and you'll see the commonality with the bit before. So Euclid states proposition 30, book 1 of the Elements. It states straight lines which are parallel to the same straight line are parallel to each other. Meaning that if there are two straight lines and those two straight lines are parallel to another straight line, then they are parallel to each other. So you're basically saying a similar sort of statement as you were before. Two things are similar to something else, or they are the same as something else. Within geometry, you could say parallel is a similar relationship. Once you have one line parallel to the other, then they are in that similar relationship. So that's the Euclid one, and obviously that gets proved. There's a QED at the bottom. It means it's obviously provable for you to be able to do that. So the form of the argument, straight lines which are parallel to the same straight line are parallel to each other. That form of argument is obviously well backed within Euclid. So what we do with that form of argument is we relate it and change it to some sort of reality, or we link it to reality. Let me just get back here, and we have a GIF. There we go. So this GIF, this is what we call t-shirt logic, and the idea behind this was to make logic so simple that you could put it on a t-shirt and get people to do that process of the finishing the argument off for themselves. So this argument states, if all horizontal planes are parallel to the plane of the horizon, then all horizontal planes are parallel to one another. Now, that's the simple argument. That's the argument laid out with the way for you to check it. I mean, obviously, you can check that for yourself by looking to see if you can find a horizontal that isn't parallel to the plane of the horizon. All known horizontals have been, will be parallel to the plane of the horizon. So much so that the word horizontal obviously comes from the horizon. There's a similar relationship there. So obviously all horizontals are parallel to the plane of the horizon, and you just check it out for definitions if you want for yourself. I could go over some of these definitions. Get some. We get some definitions of horizontal, right? Anybody can do it for yourself. Check up horizontal, and you will find the definition. Here's one. At right angles to vertical, parallel to level ground, parallel to the horizon, horizontal position. Don't worry about that one. It's a bit too triggering, that. A horizontal position. I'll get some more. If anybody wants to have any definitions of horizontal, this is from a mathematics website. Any horizon over ocean is horizontal. There's loads of ways to do this for horizontal. So I don't think it really needs me to go over too many more. This one is one. There's another one. I'll give you another one. Horizontal, parallel to the plane of the horizon, or relating to the horizon. In mathematics, this one, mathematics, measured or contained in a plane parallel to that of the horizon, horizontal. So it's pretty clear that horizontals are parallel to the plane of the horizon, and as the logical form says, if two straight lines, i.e. two horizontals, are parallel to the plane of the horizon, then those horizontals will be parallel to each other. Simple argument. Simple statement. So those will be the two arguments that I will be bringing today up for discussion. I'm willing to discuss that. Obviously, those are just the basic arguments that we can put forward. There are plenty of geometric backings to prove these, the perpendicularity relationship, the shared straight line segments of straight lines, the existence of horizontal planes in reality, because they're established by tools called levels. How long was that? Is that okay? I've not gone on too long, have I? Seem okay? I shall end my argument there, or those two arguments. Leave them up for discussion.
Yeah, sorry, I was muted. You continue as long as you want to. I don't care.
No, that's, I think, for the laying out of the arguments, that's about as much time as I need, I think. Okay, so laying out two arguments, explaining the arguments and presenting the arguments without shouting at anyone, just laying out some simple arguments. Now, remember, Blue Marble asked for the debate to be level is ... question mark, and all horizontals are ... That was Blue's request for this debate. And after interrupting me, do you want to see Blue's all horizontals are and level is? Let's see where he goes. There we go then.
Okay.
Address
Well,
we'll talk about it later. Yeah. Yeah,
let me see if I can rearrange all my stuff over here. Hang on. I think I can opt out of that and go back to this. And let's see, are you guys still seeing my screen over there in your Discord?
Let me get that.
I'm seeing it.
Yep.
Okay.
Yes, I can see it.
Well, if that's it, I'll just play this video and we'll continue after it's finished. Is that okay?
Look, have you seen the title of his video? Right, he asked me to do a debate about level is ... and all horizontals are ... and look at this opening thing of his video. That he's prepared a video for a debate. He must be nervous. I think I want to do it live. But look at it. Just presented 2 arguments for him. He's yet to provide proof. All right. If anybody needs to stop or anything of this, because you might need me to go over Blue's argument within this video. It's about 12 minutes long.
I can stop here because you already provided proof, because syllogism is a proof. So,
well,
so
not if you have a globe belief.
He's pre-prepared his video. He perhaps didn't know that that's what I was going to be doing. So he might apologise for it. Probably not. I mean,
have you ever gotten an apology for anything from any of these people that have wronged you?
Let's give him the benefit of the doubt that he's pre-prepared a video and he wasn't aware that I might be providing proof just moments before him doing this. I mean, he might have wanted to present it first. I don't know. Looks like Right to Hand's back. Welcome back, Right to Hand. You've not changed a bit. Okay, here we go.
That's fine for me.
All right.
I'll go on mute. You say about 17 minutes.
It is 17 minutes and 30 seconds, according to the 1726 or something like that. Okay, here we go.
Okay. Here we go.
Well, hello, everybody. Bev Try Thinking says all horizontals are parallel to the plane of the horizon, and he also says level is horizontal, but he has yet to provide any proof of any of that. I say, on the other hand, that all horizontals are not parallel to the plane of the horizon, and I say that level is definitely not horizontal, and I can prove it.
You can prove it? I mean, I don't know why this is such a big thing. I mean, why Betty's still doing it. It's like actual proof. It's coming in a video. Who's had it for ages?
That's what we're about to do.
Here we go. Let's go.
Now, Bev Try Thinking's logic is this. He says, if all horizontals are parallel to the plane of the horizon, P, then all horizontals are parallel to each other, Q. All horizontals are parallel to the plane of the horizon, therefore all horizontals are parallel to each other. Both valid and sound, observable and verifiable. Well, I don't think so. That's a begging the question fallacy, Bev. The premises assume the conclusion to be true. You are assuming that there is one and only one plane of the horizon, ignoring any other possibility.
What does everyone think about that? It's like, is that a valid rebuttal?
Nope.
No, because this is not begging the question. Because begging the question would be, no, it is not begging the question, because you are using the plane of the horizon. The plane of the horizon.
Wants 2 planes though, paper.
When I did this, I specifically put all in there, as in to say every single one of them, right? To make it as easy as possible to refute, right? You just need one black swan. Oh, it's like Betty did the other day, right?
Yep.
He said all verticals are not parallel. So in order to refute it, all you need to do is show 2 horizontals that aren't parallel. I mean, that's it. Dead easy, right?
Yes.
But then one of them wouldn't be horizontal.
Hang on a second.
No, I'm referring just only to what Blue is saying.
Yeah.
He is saying that Bev was begging the question. And it is not begging the question. What you can argue if this plane of horizon should be in plural or not, whatever. But within the argument, there is no begging the question.
That I think that's true, Paper, but even more plainly than getting into the question of whether or not there's a begging the question fallacy is the misrepresentation of Blue saying that Bev is assuming one and only one plane of the horizon. Bev says right above there, he's got Bev quoted. Bev says all horizontals. All horizontals plural means that Bev's argument is talking about more than one horizontal plane. In fact, he's talking about all of them.
Hang on,
implying more than one.
I want to disagree though, because I think he's trying to say that there's more than one horizon plane. Play it again.
Yeah, I know. He's still saying it, right? But that's not
more
what
than
the
one
argument
horizon.
is.
Not
right?
what
the
argument says.
States.
But that's what he's trying to turn it into.
I know, but that's what we have to point out. The argument states if all horizontals are parallel to the plane of the horizon, right? It's having every horizontal having a relationship with the plane of the horizon. Right? It's not saying that there's only one plane of the horizon. It's stating that all horizontals have a similar relationship to it. I mean, tell me you don't know what the plane of the horizon is. That goes to Blue as well. I mean, every time you say the plane of the horizon.
One of those.
Yeah, but every time you say the plane of the horizon, are you saying that there's only one? Or is it like a unique signifier of something that you know exactly what it is?
Right, I get you.
I mean, like, what you could do is you could look at the plane of the horizon in front of you and turn round and look at the plane of the horizon behind you. Are you saying that's the same plane of the horizon? Or is it two different views? Are you looking at different things while still understanding what the plane of the horizon is? I think it's a weaselly way of Blue trying to avoid the conversation, right? It's obvious ECV for me. Any way to avoid the actual argument.
The question I have here, Bev, is do we think that he got this from Betty?
No, that's both valid and sound, observable and verifiable was wrote by DP. So he's picked this up from a meme somewhere.
Okay.
I didn't even bother. I don't bother with that valid and sound and all of that. It means nothing.
It definitely means nothing. We saw that a little bit today, as a matter of fact. Yeah. I would say just by virtue of he may have been talking with Betty about this, and Betty may have helped him craft this because of the faulty logic that Blue is using in the yellow there. Just the idea. I mean, Paper's right. It's technically not a begging the question fallacy, but the idea that you would try to utilize a quote that clearly states horizontals as plural, and then claiming that your opponent is stating that they assume one and only one plane of the horizon sounds like Betty to me.
Well, Betty went with the cross on it, didn't he? Like that. Betty chose a different way to refute this, so don't think it is coming from Betty. They would have solidified their argument together, wouldn't it? But Blue's going for something different. He's just saying it is. But like what he does is he puts in inverted commas, plane of the horizon. Well, no, it's called the plane of the horizon, right? Correct. That's what everybody calls it. So why miss the plane? of the horizon.
By the way, if this is begging the question, and you should imply more than one plane, so it should be planes of horizons, but we cannot see horizons.
Yeah, that wouldn't be.
We can see one horizon. So from one horizon, you can make only one plane from that line, this true horizon or whatever you can call it at the sea. You can see one line of the horizon, and this is horizon, this line where water meets the sky, etc. This is a line. So one line. So from that one line, which is horizon, you are creating the plane, not planes. Why planes? Other plane would be, might be parallel, but that would be not plane of the horizon, because that plane would be parallel to horizon, plane of the horizon. So that would be horizontal plane, but not of the horizon.
Yeah, it was made as a simple argument. I mean, I think everyone can follow along with it, and it's pretty obvious that, you know, like Betty struggled to what a square was and a plane.
Yes, my point is that I am rebuting his begging the question fallacy accusation, because from one horizon you can make one plane. So, so the statement that are parallel to the plane of the horizon is correct. And if you would put there planes of the horizons, that would be incorrect. That would be incorrect. Blue marble science would say then that, okay, I am okay, because now it is not begging the question, because Bev is assuming more than one plane. But to assume more than one plane, you have to assume more than one horizon, and it is impossible because we can see only one horizon. Sorry. So it cannot be begging the question. I'm done.
Betty's come in. Well done. Good to have you here. Betty, I would say logic is the science of reasoning. Not valid argument. Come on. The science of reasoning. Betty. Using your mind. Valid argument. Yeah, it's not a begging the question fallacy, because he's forgetting that there is backing from Euclid, right? So begging the question would be to assume your I don't know, but I'll leave that one to Blue and Betty. They seem good at explaining what it is, begging the question. It sounds good though, right? I mean, a lot of people would probably be, well, that sounds good. Yeah, Blue, obviously it's a begging the question. It's not. It's a pretty good argument. Should try rebutting it at some point. We go.
Now, this is Bev's contention. If there were one and only one plane of the horizon, Bev might be right. But what he's asking you to believe is that a line, a horizontal...
He's done it again. He said, if there were one and only one plane of the horizon. No, it's called the plane of the horizon, Blue. Just changed it again.
line parallel with the plane of the horizon in Miami, Florida, also has to be parallel to the plane of the horizon in Jacksonville, Florida, or in Boston. This is pure speculation. No testing or proof whatsoever, just a simple statement. The other possibility is if the Earth is an oblate sphere, then multiple planes of the horizon have to exist. Gravity vectors, so that's verticals or zeniths, can't be parallel, and horizontals, which are perpendicular.
Sorry, can you stop here?
Yeah.
Because what he is doing now.
Yeah.
He said that you should make another horizon in different location, and you would see that they are not parallel, these planes of the horizon. This is what he's saying. And assuming that they are parallel, in his example, that would be just a speculation. So he is making speculation for you, and he's refuting this speculation. And he is suggesting that he's refuting your argument. No, he is refuting his own argument, which he called speculation. And now he is refuting his own speculation. So this is what he is doing now, for people to know what he is doing in debate.
The other possibilities called it.
Yeah, but this is his invention. This is his speculation, not yours.
Yeah, he's not actually bringing his own argument, or maybe this is. It seems like a rebuttal to my argument as well, really. But
yes, but he is creating his own speculation, and he is rebuting this speculation as your argument.
It's a straw man, right? He's
kinda, yes.
Making a semi-straw man. I mean, half-arsed. And he's led by, obviously, the model's dictating to him what he has to do. It's a valiant defense, right? But predictable.
To those verticals also cannot be parallel. So can we test this? Well, absolutely. We need two things. We need two fixed points, like a point there and a point there. And we need a
That's 2 points.
Way to measure angles A and B. And we'd like to do that simultaneously if possible. So how does that help us?
You can see this shape he's making here. It's familiar, doesn't it? We've been going over this. It's great.
Yep.
Well,
I'm not watching, but is it a Donegon?
No, it's proposition 5.
Oh, parallel postulate. Okay.
No.
Yeah, I'm watching now.
It's isosceles triangles.
And Euclid's Elements, Book 1,
Similar
Proposition
triangles.
29, which says, a straight line falling on parallel straight lines makes the alternate angles equal to one another, the exterior angle equal to the interior and opposite angle, and the sum of the interior angles on the same side equal to 2 right angles. And further down we see Euclid say this, therefore the sum of the angles BGH, that's that one, and GHD, that's that one, also equals 2 right angles. BGH plus GHD equals 180 degrees.
You will note here, please, I hope everybody's noting, Blue Marble Science is using Euclid, proposition 29. It's quite a good one for him to use, this one. But it is definitely Euclid, and he's talking about 180 degrees being here. Much like in Euclid, triangles have the sum of 2 right angles also, and a straight line. No more.
Can I ask?
Go on.
Can I ask something? Well, I'm just thinking this is still early in Euclid, so this is all 2-dimensional geometry that we're dealing with.
Absolutely. This is the first time, around about the first time the parallel parts get mentioned.
Well, I'm just wondering how he applies all this 2D geometry to the Earth. which is 3D.
He's about to do it now. He's about to show you.
Yeah.
Yeah.
That's what I'm waiting for.
Well, we call this the stolen concept. Or really, it's a self-refuting claim. But he doesn't understand that just yet. And I'm not so sure whether people will, but hopefully you can catch up at some point.
But what happens if lines AB and CD are not parallel with each other? What happens if they look like that? What happens if they are converging? Well, in that case, BGH and GHD have to be less than 180 degrees. That's easily provable. On the other hand, what happens if they look like that? What happens if they are diverging? Well, in that case, BGH and GHD have to be greater than 180 degrees. So the measurement process, we can test this with two theodolites. Those are instruments that precisely measure vertical and horizontal angles. We can put a theodolite at each of two positions.
There's the 3D switch.
And measure.
No, this is he's doing the reciprocal theodolites, but I mean we're gonna do auto levels. This is how we do the rumpus pole simultaneous below. We've got them covered. Sort of the inspiration for it.
Measure the vertical angle to the other theodolite. We'll put a theodolite there, and we'll put another one over there. We'll point those two theodolites at each other, and we will measure angles A and B. Now there's.
See, you always know when you're dealing with blue marble geodetic surveyors, right? Because what they do is they like to point tools at each other. They like to get the tools out and point them at each other. You can always tell that this doesn't happen with like what we call it, normal surveyors, like normal geodetic surveyors, or maybe plane surveyors, or the local surveyors that you see around the place, right? That just survey locally. Now these are special blue marble armchair. Well, I mean these ones aren't, because they're actually out there pointing theodolites at each other. But you can always tell. Obviously, blue marble surveying techniques, pointing tools at each other.
There's our little sketch from Euclid. Let's turn him so it looks a little more like our verticals here. And you can see that if the verticals are parallel, angle A plus angle B has to be equal to 180 degrees. It has no choice. They don't even have to be at the same elevation. The theodolites could be at two different elevations. You just need to be able to point the two theodolites at each other. So if Bev is right, and all horizontals are parallel to the plane of the horizon, meaning all horizontals are parallel to each other, then all verticals must also be parallel, and the sum of internal angles, in other words, reciprocal zenith angles, has to be exactly 180 degrees, as Euclid Book 1, Proposition 29 says. But what if
Euclid doesn't really say much about pointing theodolites at each other. In fact, I'm pretty sure he doesn't.
Yes, and he's messing orthographic view with perspective. So, because this red line, that would be, I don't know what it is.
It's just a line. It's just a theodolite looking at another theodolite.
Yes, but looking at means that someone is looking, and maybe it is or should be line of sight in his view, but it isn't.
Yeah, he's got no rumpus pole to look at, so they have to look at theodolites, right?
Yes, but in perspective, theodolite is smaller than than this theodolite at which you are looking. So your theodolite in perspective is greater than this distant one.
Yeah, you're going to end up with the equipotential angle, right? Because
Yeah,
you're measuring angles, so that's what they're after. equipotential angle of adjustment. It's on the way, right? You can see the process though, can't you?
Yes, this process is made by ignoring perspective. So they have to ignore perspective.
It's not often performed. I don't think there's many people that have actually done this. There's a couple of shadow giants, right, that have actually been out in the field pointing theodolites at each other. I don't think they're around anymore.
Jesse Kozłowski
he's
did
gone.
that, yes.
He's gone, sadly. And I think they're still surviving. I think Larry Scott or Larry GPS, or I think he's more commonly known by the name of Shoebill. Now he goes by the name of Shoebill. Shout out Shoebill. You might be needed to explain the noble art of looking at theodolites through theodolites. I mean, well, it's a well-known geodetic surveying thing. Well, blue marble surveying technique made up by Jesse Kozłowski and Larry. So take the floor anytime you want. This is obviously blue marble's never looked at a theodolite through a theodolite, but he's going to now tell you exactly what the process is and how it works through blue marble geodetic surveying. So here we go. But blue marble's definitely an armchair blue marble science geodetic surveyor.
Horizontals are tangents to a spherical surface. Then horizontals can never be parallel, nor can verticals be parallel. The sum of the internal angles A and B will be greater than 180 degrees in every case if the surface of still water or points of constant elevation form a curve. By golly, we got us the makings of a test.
Didn't I just went through the one with equal elevation as well before and said, you know, that it was the same as the horizontal, but seems to have missed that. So he's going straight for the new science test.
Bev, let me introduce you to a couple of guys. One guy named Jesse Kozłowski and another guy named Larry Scott.
Unfortunately, Jesse Kozłowski has had to do a Jesse Kozłowski leave the arena. He said some really stupid shit. He obviously can't back up. So he's just gone. I don't know whether he listens in every now and again. Maybe. I doubt it. It's probably too painful for him. But Larry Scott, as we said, he's still in the arena. So shout out to Jesse Kozłowski. I know you're not around here anymore.
Doing a Jesse Kozłowski.
Yeah. And Larry Scott, Shoebill. Back in 2018, like quite a long time ago, they were looking at theodolites through theodolites. Quite a long way. So here we go. Look, Hagerstown. I think we were looking at this the other day.
2018, those two guys got together at the Hagerstown, Maryland airport at High Rock Lookout, about 11 miles apart, and measured reciprocal zenith angles. How about that?
Wow. How about
Larry
that?
was at the airport over there. That's Larry's theodolite and the signal mirror. And Jesse was up on top of High Rock Lookout. You can see where Jesse was located, where that red arrow is.
There's an arrow there.
Those two guys measured the two zenith angles. We'll call the one at the airport A and the one up on High Rock Lookout B.
Those look parallel, don't they? The heights for the elevations on that graph. Would you?
Yes.
Okay.
So they were measuring allegedly from a straight line, horizontal.
From this, yeah. These look like the parallel. Don't know whether they are. Maybe. I think this is Google, and I think that's the way it does it. You know, it lays out an elevation profile to a straight line. So, I mean, that's what they were doing. They were out there measuring this angle and this angle. Well, actually, they were looking at each other. So they were pointing it up in the air and measuring an angle down to each other, right? So they were ending up looking at a theodolite.
And here are the actual measurements. Larry measured angle A to be 88 degrees, 57 minutes, 58.2 seconds. Jesse measured angle B to be 91 degrees, 9 minutes, 55 seconds.
So, each of them have an angle. And you know what we say about that? Well, you get two geodetic surveyors with an angle each. Well, magic can happen.
That is a total of 180 degrees, 7 minutes, and 53.2 seconds. 180 degrees.
Can I ask
7
a question?
minutes,
Hang on, man.
and 53.2 seconds.
Is that some
yeah. Are seconds and minutes units of distance measurements?
No, they're angles. It's an angle measurement.
Okay, I'm good.
It's a little bit over. It's a fart of an angle, right? You get a degree, and then you divide that degree into 60 components, and you call each one of those a minute. And then you get one of those minutes, and you divide that by 60, and you call them seconds.
Like in the clock. The same.
Minutes and seconds, 60s and 60s. So a second is a 3,600th of a degree. And a degree is a 360th of a circle, a unit circle. So yeah, he's added a little bit here. It's a little bit extra. Right? I mean, these are two of the most qualified blue marble shadow giant geodetic surveyors, right? So obviously accuracy rating spot on, 100%. They never make a mistake, even over whatever distance. There could never be an angle measuring problem with them. That all they have to do is measure one angle each, right? And then they can combine them, like Blue Marble says here, right? So this is what you can do. You say you can do fuck all with an angle. Well, these shadow giants combine them. And
that is with no refraction correction. If you include refraction, that increases from 7 minutes, 53.2 seconds to about 9 minutes and 40 seconds.
Wow. So you add on a minute, so nearly 2 minutes for refraction with your angles. Obviously you don't. You just measure an angle. You don't add refraction on as an angle, an extra. Plus, it's like lengthening your rumpus pole. I mean, like you wouldn't do that, would you? He was telling us the other day, you can't lengthen a rumpus pole. You've got to shorten it. So making the angle bigger sounds a little bit silly. But hey, that's blue. That's blue.
Here's Larry's diagram with a little more detail on it. Again, there are the two angles that...
Larry's diagram. Has anyone ever seen this? Did you think it was an official technical thing? Or did you know it was just Larry's diagram? Some random dude posting some stuff. He's been on the top of a mountain, right, Larry, with a theodolite, looking at a theodolite, measuring an angle. Very clever. And he's done this. I mean, look at all the numbers on it and stuff. He was here measuring an angle. I've got an angle here.
Those guys measured, and there is the sum of those two angles. 180 degrees, 7 minutes, 53.2 seconds.
I did two angles.
That's 7 minutes, 53.2 seconds in excess of 180 degrees. Now, just in case you thought this was a one-off,
yeah,
this is a report done by NOAA back in 1978.
Just in case you thought that two old dudes, one of them is not around anymore, actually just measured one angle each and combined them. Well, no, look. Lou's got a book.
It's a survey of the McDonald Observatory radial line scheme. They were measuring reciprocal zenith angles from 7 different positions to a place called Baldy. Here are those measurements. In the interest of time, I'm not going to go through all of this data, but I will call your attention to a couple of columns here. That one and that one.
Look at this.
The first one is the sum of the zenith angles. The second column is plumb line tilt. That is simply the sum of the zenith angles minus 180 degrees.
He did just say plumb line tilt.
Plumb line tilt.
Yeah. As though it was nothing, right?
Tilting plumb lines.
Didn't even.
Yeah, I wish I could get
himself.
to the freaking mute button faster. I wanted to say that. Like, who even thinks of plumb line tilt?
But it's got a column there. Like, this is, you know, like somebody's wrote it down.
Official government document.
Yeah.
Isn't that just saying that the difference between the vertical at one location, the vertical and the other?
Same plumb line tilt.
But that's what it is. He's saying the some of the zenith he's saying the sum of the zenith angles is greater than 180 degrees. So that's saying that there's a difference in angle between the two plumb lines, and he's calling that plumb line tilt. But
I know.
It doesn't mean, So
we've got equipotential angle of adjustment, right? It's much better than plumb line tilt. I mean, plumb line tilt sounds fucking ridiculous.
A rose by any other name would smell as sweet, right?
No.
Plumb line tilt.
No, this
sounds
smells like
fucking
shit,
stupid,
dude.
right? That's ridiculous.
But no,
This smells like total dog shit.
It is the equipotential angle of adjustment. It's the same. It means the same thing. The calculations are giving you the same number.
But I mean, it just sounds ridiculous. You can't go round saying to people that you've got plumb line tilt. Like, it's got a column called plumb line tilt. I mean, it doesn't happen. It can't happen. It is an angle of adjustment, right? The equipotential angle is the angle measured between these two things. But, I mean, it's not plumb line tilting. Plumb lines just don't tilt. It's fucking ridiculous.
You call it what you want. I think the important thing is that, like, they're measuring that these two plumb lines are not parallel.
Well, he's measuring an angle, right? And then calling it plumb line tilt. That's all that's going on at the minute.
No.
We've got two guys.
If those two plumb lines are parallel, the sum of the zenith angles would be 180. So what he's saying is that the two plumb lines are not parallel, and the difference between the two.
No. What he's saying is there's two guys that are measuring angles, and they're combining the angles and putting that number that they have that when they minus 180 from it in that column and calling it plumb line tilt. That's what's going on.
I know, but the what the number is the difference in angle between those two plumb lines.
No, it's not. It's when you add the two angles together
plumb lines,
and minus 180, you get that angle, right?
Yeah.
Okay.
If the plumb lines are parallel with each other, you would get an exact angle when you sum the zenith angles of 180. If
with an
not
optical
parallel,
device, no. The optical devices don't work like that.
No, if you're measuring the sum of the zenith angles, not accounting for refraction for the moment, if the sum of the zenith angles is 180 degrees, then those two plumb lines are parallel. If it's more than 180 degrees, they're different.
We get, everybody understands that there's two guys measuring angles, one at A and one at B. They combine these two angles, minus 180, and get that angle. That everybody understands that's what's going on. Like, you don't need to come and tell us exactly what's going on again, right? We understand.
Two optical devices, not meant to look at one another from a distance of 17 kilometers away or whatever it is, looking at each other from 17 kilometers away, getting an angle apiece, and then claiming that it's plumb line tilt. That's what we have
Just
here.
put it in a column.
Don't try to
called
put
plumb line
lipstick
tilt.
on the pig, dude. That's what's happening. Embrace it.
Yeah.
We
What's
would never
happening-
call a
that-
plumb line tilted.
So you're just haggling over the name. That number.
Yes,
What?
we are now going to carry on. Yes, it was just pointing out that he's got a column called plumb line tilt, and Blue Marble thought nothing of it. Right? He's breezed past it. You're here defending it. Right? I personally think it's fucking ridiculous.
You can think what you like. I
know.
understand
That's
what it
all
meant.
we were doing. We were just pointing out.
Good for you. Excellent. Carry on.
I have one notion about this looking at theodolites through each other. Because Ramshutu said that let's ignore a refraction. But if you are looking through optical device, my question is why you are going to ignore perspective. You are not only ignoring refraction, but you are ignoring perspective. So that's why this looking through theodolites is invalid as a measurement.
It doesn't. The perspective element doesn't matter. The only impact perspective will have in this.
Wait, whoa! You can't. You can't say
Come
that.
on, let
because
him
you're using
be the
optical
globe
device.
apologist. Come on.
Okay.
Let him go.
Okay,
but
the impact perspective will have at that is to amplify the margin of error in your calculations, because what you're trying to focus on is smaller. All of these measurements are angles. So as things get further away, the angle will drop to towards 90 degrees. But the sum of the zenith angles essentially removes the impact of perspective because you're summing it from both sides.
Okay, brilliant.
So
Thank you very much. Can we carry on now? Right, we don't need a lesson because Blue Marble's doing that for us in this thing that we're going over. Or unless you think Blue Marble's going to make a mistake. And you don't want to preempt him, do you?
I think he's thinking Blue Marble's doing a shit job here.
I think so.
He's got to
That's what it sounds like.
Got to come in and explain it because it sounds fucking ridiculous. So, yeah, we've got to explain it because plumb line tilt. Go talk to anybody about plumb line tilt, especially if they know what a plumb line is. Just go tell them. Yeah. Did you take into consideration the plumb line tilt?
And they tilt from what?
The equipotential angle of adjustment just sounds.
This is the problem. This is the problem with academics versus people who do things in the real world.
Amen, brother.
Oh, thank you very much to the subs. Join in. Well done. Is that Godzilla again? Thank you for everyone that just got a membership from you. Okay.
Thanks, Gorge.
Can we carry on for a bit? Because this is, I think, this is some of the good stuff.
This was
We've been
entertaining.
waiting for this for quite a while. And I don't know, is that Rams that came in? You may be new round here. This is a long, ongoing discussion that we've been having. Very geometric, and this is about logical and arguments. Blue Marble's trying to present an argument. We thought we'd go over this, so give him a chance.
Notice that every one of them exceeds 180 degrees. The smallest is 15 minutes, 53 seconds, and the largest is 44 minutes, 33 seconds. So, now for the unavoidable truth. The zeniths are always doing this.
There you go. Always.
So the horizontals are always doing that. Now for the conclusions. The sum of reciprocal zenith angle measurements always exceeds 180 degrees, therefore verticals are measurably not parallel. Horizontals, therefore, can never be parallel. And Bev's assumption that all horizontals are parallel has been shown to be false. Well, there's conclusive proof that horizontals are not parallel.
So there's conclusive proof from Blue Marble Science that horizontals aren't parallel. Verticals as well. I'm not too sure he understands the consequences of that, the full consequences of it. But hey, let's pretend that horizontals still exist for a bit. Let's see where he goes from here.
All done and dusted. So let's move on to the fact that level is not horizontal, and we can prove that too. Let's talk about flagpole measurements. We probably all did this as a kid. You go out to the playground to the flagpole, measure a distance away from it that you know. You stand there with a protractor and a string with a weight on the end of it. Get your buddy to read the angle as you line the protractor up with the top of the flagpole. And if you know how high the protractor is at that point, just a little simple math and voila, you get the height of the flagpole.
It's about the angle. I think they really like angles. There's something to do with the flagpole there. That's away from the place at A. But I'm pretty sure it's assumed parallel at that distance away in order to form.
Yeah, but still, if you have these flagpoles and supposedly they are on the same level, and you can measure or see the drop because this farther flagpole is smaller. So if it lies on the same, let's say, plane or the same level, it is smaller, so it is dropping. So the angle would be smaller. This is how the objects are changing angular size in perspective while looking through lens. And
he's only measuring an angle, right? He's at school.
Yeah.
They're measuring angles to the top of flags. Like you said, this is a schoolyard thing.
Yes, but still, but my point is that he is using this difference in angles as a proof of divergent verticals. But this is well-known thing in perspective without any divergence. It doesn't prove divergent verticals.
Is that not what you call stolen concept, though, right?
Yeah, completely, yes. So this difference in angles is from due to perspective only, solely. It has nothing to do with diverging verticals. So sorry.
If anybody's listening in, right, if you can spot the stolen concept within this that Blue Marble's about to do, and let us know. Postcards, answers on postcard, or just type it in the chat.
They do that in reality too. Surveyors do this all the time. At times, all they're doing is trying to figure out how high a power line is over a road or something like that. But you can do it for other reasons too. And the interesting thing about it is this. If your baseline is mean sea level, for instance, it doesn't make any difference.
Anybody see anything there in the picture? You notice he's only got one height of A. A looks like it's perpendicular to both that line B and the mean sea level. Typical.
Where you put that theodolite, if that were truly a flat baseline, you can move the theodolite anywhere you want, and you'll still be able to calculate the correct height of a distant object like a radio tower. But because horizontal changes as we move over a curved surface, the trigonometric height, in other words, the calculated height of the tower above mean sea level, appears to change. The further away you go, the more it will drop. The closer you get to the tower, the higher it will be. And it's simply because this. That's what level
perspective
is.
Yes, not, but he's depicting orthographic view, and now he is explaining how perspective works.
No, that's not quite correct, because
yes, it is.
If it's further away, the angle alpha will be smaller. So the tangent relationship is showing you the angular size due to perspective. And he's saying that if perspective is the only impact, then you'll be able to correctly calculate the height of the object above mean sea level just by using the angular size of the object, alpha.
Angular size of the object?
Yeah, so alpha is the angular. No, the alpha there on a flat surface. Alpha on that diagram there is the angle to the top of the object, which you should be able to calculate based on perspective accurately. But he's saying you can't because there's an additional change in angle due to the curvature of the Earth.
Well, no,
so
it's not an additional change in angle due to the curvature of the Earth. It's an additional change in angle due to the equipotential angle of adjustment.
Which is down to the curvature of the Earth. Yeah.
It's down to the equipotential angle of adjustment.
Which on a globe is down to the curvature of the Earth, because the two are at different.
Difference between an orientation in one place and an orientation in another place. It's the angle between those two orientations. It's an angle. It's an angle. Don't confuse people.
I'm saying what the cause of the angle is. It's because a different position on the surface of a curved surface.
No, it's because it's between two straight lines, as all angles are.
But the equipotential angle of adjustment is occurring because two objects have a different orientation because they are different points of on a curved surface.
No, those orientations, you've got to say they're straight, right?
With respect to what?
The orientation.
With respect to what? Orientation.
You're measuring an angle from one orientation to another. An angle is the measurement, the inclination of one straight line to another.
Yes. And
right, so those orientations are straight lines, for fuck's sake.
Yeah, you seem to be confusing what I'm talking about. I'm saying that you're kind of saying I'm wrong, but then also explaining exactly the same thing.
No, you're trying to say it's a curve. It's not. It's an angle. Well, measured between two straight lines. Those two straight lines are the orientations in two different positions.
And that orientation is due to being at different positions on a curve.
No, you are just adding this curve. This is imaginary curve.
No, it's an angle.
It does not exist.
It's an angle that you're adding, not a curve. Please don't equate an angle to a curve. It's just an angle. There's enough problems coming from angles and magic angles and all of that sort of stuff. It's going to be hard enough. Please don't try and equate an angle to a size and an angle to a curve. It doesn't work like that. You can't load too many things onto an angle. It's just an angle, for fuck's sake. Didn't do anything wrong. But have you spotted the stolen concept yet? No? Shout out when you hear it.
When we reorient the Theodolite like that, now we have a different horizontal. That's horizontal at the tower. This is horizontal at the instrument. So effectively, this is what happens. The tower now only looks like it's that tall.
Not perpendicular. Maybe a little bit of a problem, but you've just got to add in the equipotential there, right? And then it's okay. You get it back again.
Well, in reality, we've got a real tower here. This is one from Larry Scott. This is not far from High Rock Lookout, about a mile.
It's got a height there, right? Obviously, they've built the towers. For radio signals, so they know already how high the towers are. Of course they do. They know how high the mountain is. They want to know how far the signal goes, so they want to get it as high as possible so they can do that. So they know already the heights of this sort of stuff. But Larry does this as a hobby.
Or so away. There's a big red and white tower up there with a strobe on it. And Larry can see that thing from all over the county. Over a span of a few years, Larry has made measurements of that tower from a lot of different positions, 23 actually.
Angles. Larry has measured 23 separate angles. Let's give him a round of applause, right? Larry's special. There's not many people that do this, but Larry dedicated to this.
Whenever he found a place where he could see the tower, he would stop when he had time, get out his Theodolite, and take some readings.
He's like, what's he doing? It's that dude that likes to, whenever he sees the tower, he has to measure an angle to it.
It's a plot of all the positions Larry measured from. I've shown the longest one there. You see the tower in the lower right.
Look, he records where he is. He's measuring an angle to that tower. He likes it. I think the tower's always the end point of his angle measuring. Don't think he ever starts at the tower. It ends at the tower.
He got one measurement from 27.7 miles away.
27.7 miles? It's a long one.
Here's all the data. The top number is the elevation of the tower that Larry was able to calculate, not the FAA elevation. This is Larry's calculation based on all of his measurements. And it's within a...
So it's not the official. Larry doesn't go with the official one. He does it for testing himself.
Few feet of what the FAA says.
Few feet.
But there's something interesting here. Notice the very first measurement was from 27 miles, and his instrument elevation was 1961. He's about 390 feet lower than the tower. Oddly enough, he's having to look down to see it. You see in the right-hand column all of the tower height calculations that Larry made, and they're all over the place. That's because that is the calculated height of the tower without considering Earth curvature. When you plot that data, it looks like that.
See, that looks smart, that, doesn't it? Look at it. That's that's what you'd expect to see for your rumpus pole graph. I think, like all of these distances here, like I call them verticals on this graph, but I don't know whether that would be the correct term to use. But that would be the length of your rumpus poles, measured like that. On the graph, he's done well graphing it.
You see that pretty curve? It's almost a perfect fit. R squared on that data is 0.9999. I decided to take a look at a couple of points. That point and that point. Well, you can see.
Have a look at him. Look at him. Blue's put circles round him. He's having a look at him. Focusing in on those points. Look. He's done all the numbers for it and everything. It's focusing in on them.
See that at the distant target of 27 miles, the predicted drop's 431.3 feet. The measured drop is...
Remember, this is Blue Marble doing this for a debate. He's done all of this himself, hasn't he? It's like it's a pity he couldn't do it live. Almost as if you'd think that Blue might have actually done this himself, wouldn't you? Not just going off a story that Larry's told him.
434 feet. That's 2.7 feet difference. It seems to be fitting 8 inches per mile squared pretty well with refraction. Same thing on that center point. 145.7 is the predicted drop based on my calculation. 144 feet is what Larry got. That's 1.7 feet different. Larry went ahead and took off.
It's 1.7 feet different. Blue calculated it and Larry was 1.7 feet different than what Blue calculated.
All that data and applied both curvature correction as well as refraction correction, and you end up with a straight line, nearly perfectly straight.
End up with a straight line.
Nearly perfectly.
Plot it. Yeah. Yeah. So plots it all. If you do something with those curved lines and do it, you get a straight line. Yeah, I think he did say he had to measure an angle down, like, yeah. measure an angle down. I don't know whether you said below or not. Do you want to just check?
You got one measurement from 27.7 miles away. And here's all the data.
There we go.
The top number is the elevation of the tower that Larry was able to calculate, not the FAA elevation. This is Larry's calculation based on all of his measurements. And it's within a few feet of what the FAA says. But there's something interesting here. Notice the very first measurement was from 27 miles, and his instrument elevation was 1961. He's about 390 feet lower than the tower. Oddly enough, he's having to look down to see it.
Having to look down to see it. Yeah, down.
You see in the right-hand column
300 foot.
all of the tower height calculations that Larry made, and they're all over the place. That's because that is the calculated height of the tower,
So
not more than 3 feet apart. So that's Earth curvature you're seeing. That is level deviating from horizontal. But we can do that with just observations to more than as refract as what Larry got. That's 1.7 feet different. Larry went ahead and took all that data and applied both curvature correction as well as refraction correction, and you end up with a straight line, nearly perfectly straight.
You do curvature correction to your data to end up with a straight line. Really? Well, that's handy. I like that. I suppose it's easier to deal with straight lines, isn't it? Correct your curves into straight lines.
Notice that vertical scale. Those blue dots are not more than 3 feet apart. So that's Earth curvature you're seeing. That is level deviating from horizontal. But we can do that with just observations too.
That's level deviating from horizontal when you do the curvature corrections to make a straight line. I think.
Here
we go.
An auto level is a great device. We set an auto level up. It establishes vertical by referencing itself to gravity, and it makes a horizontal plane of reference for you, which is 90 degrees to the vertical. That horizontal will extend all the way to infinity, but in reality, you're going to become limited by what you can see through the atmosphere. Now, if the reference surface were flat as that's being shown, that horizontal will always be the same distance above the reference surface, always.
Always.
If it's 5 feet at the Theodolite, 30 miles away, it will still be 5 feet above that flat surface. The problem is, that's not what the Earth looks like. The Earth looks like that. And the gravity vector is different, and horizontal is different, as we've already seen. So let's move on to an observation that Bev really hates, and it's Blackpool Tower.
So I thought he was about to show us here.
Not more than 3 feet of surface, always.
I was waiting for the rumpus pole. I was waiting for him to tell us to do the reciprocal rumpus pole, but I don't. It may have been. This is a bit a while ago, right? So he's obviously focused on only the single.
Yes, but he stated one important thing. He said that this distance between horizontal and level, I think, or maybe you can put you can rewind a few seconds when he's saying that, because I don't want to misrepresent what he said.
Okay.
If it's 5 feet at the Theodolite, 30 miles away, it will still be 5 feet above that flat surface.
Yeah.
The problem is, that's not what the Earth looks like. The Earth looks like that.
Yes.
There you go. Do you want to carry on a little bit more, or are you okay with that?
It is okay. This is what he said. This is essential. So he's saying that this 5 feet difference between level and horizontal would be at the 30 miles or whatever distance would be 5 feet. So of course, it means implies that if level is curved, it means that horizontal has to be curved also. But nevertheless, he is saying that this is not like it how it looks like. So he is referring orthographic, let's say, picture, so reality, with what we see through Theodolite, so with perspective. So he's confusing, because of course this is an important point, that we see things in perspective differently than they are in reality. So things that are at the same height in reality, this 5 feet, they are not at the same level in perspective. Simple.
Yes, yeah, but he's not. You know, they're not bothered about perspective or anything like that, right? What he's done. There's a shadow giant that's sadly no longer around, right? Jesse Kozlowski. Jesse Kozlowski said that level drops from horizontal. So exactly like Blue's showing there. It drops away. It goes down. Drops down, like Jesse said. It drops away, drops down from horizontal. And that's exactly what you're seeing in the picture there. That's why Blue's doing it. Shadow Giants told him.
Yes, I know.
Can I just add one thing? No, sorry, Paper. Just let me add one thing real quick. Our vision ramps up, yet they're saying it's going down.
No, they're
But our
saying level
vision
drops
ramps
away
it
from
up.
horizontal. Like, look.
Yeah, but when you look through the tool, it's ramping
No,
up.
you're not talking about that. We're just talking about Blue's argument here. He's showing that level drops from horizontal. It's there in the picture. You don't need to read anything else into it. Like, don't be clouded by what you might be seeing, right? Jump in my shoes, right? We're seeing this from the first time.
Yes, he's not showing perspective view, what we can see through Theodolite. He's showing orthographic view.
Mm-hmm.
So like reality.
Well, you're going to see it in a minute. He's going to go and show you. He's seen a picture. He's seen something. And that's where he goes. So here we go, look.
And the gravity vector is different, and horizontal is different, as we've already seen. So let's move on to an observation that Bev really hates, and it's Blackpool Tower.
Right, now, he says that I really hate this. Well, you can see me in the picture. So, I'm not too sure I really hate it. But you can see me in the picture, right? That means that a camera has been fitted to an auto level, invalidating the tool for any surveying purposes. And that screen has been broadcast into Discord. And this is the video that's resulted from it. So Blue's going to do that. But I mean, this is the actual thing that you would see. Well, not actually through an auto level, but it's what you'd see if somebody strapped a camera to the back of an auto level and broadcast the picture into a Discord. This is exactly what you would see.
Yeah, but according to Blue Marble Science, your height is nearly the same as Blackpool Tower height. So you have, I don't know how high.
Well, I think that's
Blackpool
about 100 feet. That bit.
Yeah, so Bev is very tall man.
My hat is around about the same 100 feet. You know, like if I was in Blackpool, I'd be a few stories high, according to that, or whatever. Yeah. I mean, but that is like, it is just a camera on the back of an auto level. That's it. I don't know why Blue seems to think. And also, see the picture on the left? The one that he's got of Blackpool Tower? Well, that's taken from out in the seafront, at the front of It's a completely different angle. It's a lot closer. It's just a picture of Blackpool Tower. Blue does this a lot. He likes to just do association things. So this is what this is. It's just a picture of Blackpool Tower. Just so you know that this is Blackpool Tower. He likes to think that there's some other associations, but I mean, there isn't really. And like, yeah, well, let's see what he says.
Bill's auto level is set up and the crosshair is just a few feet above sea level. Probably less than 10. Google Earth says that beach he's standing on is at sea level. But look 13 miles away.
So he knows where we are, right? The actual beach is sea level. That's interesting, isn't it?
At Blackpool Tower in the distance, and the crosshair is 100 feet up on that building. I'm going to fade in a picture of the actual building. There's the crosshair. There's a red reference line. Now watch the building. I'll fade it back out. Keep your eye on it.
Look,
and the match is almost perfect.
Almost perfect, Blue, and he's blending Blackpool Tower in and out.
Same thing we see in Bill's photograph. That's where the crosshair is striking that building. And that is about 95 feet above sea level. So that's reality.
Right, so I mean, let's see where
we have an auto level that's establishing a horizontal plane of reference.
That's what we've seen.
We got Bev in the foreground, just 400 or 500 yards away. But we got Blackpool in the distance, 13 miles away, and that 5-foot high auto level above that beach surface should be striking Blackpool Tower 5 feet above sea level, if level is horizontal. Problem is, level is not horizontal. The auto level crosshair is on Blackpool Tower at about that point.
Hey, look. See this?
That's because that's what the Earth looks like.
So, what you can see here is, well, I mean...
No, I'm sorry.
No, there is a problem, right? This is why we're going to go to Bedford and do the reciprocal, right? Because it's never been done. How do you know, from looking at this, that Blackpool Tower isn't just lower? How do you know? It's like it's just lower, isn't it? Obviously, it's got to be. It's a drop from horizontal.
This is just what I call perspective drop, and this is normal thing. So I don't relate that into with any curvature of the Earth or whatever.
Oh, it's obvious that the Blackpool Tower is below, right? Blackpool, at least from looking at that from Southport, like Blue Marble says, the armchair geodetic surveyors looking at pictures from invalidated tools, obviously, and looking beyond the range of the normal ones, and doing some little bit of blending with the camera work and all that. But I mean, look at it. It's below. It's a drop from horizontal. How do you know that Blackpool just isn't lower?
So what you're suggesting, just to make it clear, is that the reported elevations are wrong.
Okay. Well, no, I mean, like, look at Blue's picture there, right? Blackpool Tower obviously is lower, isn't it? Down.
Yeah,
just
you're
like
saying
Jesse
it's obviously lower,
says.
right? But we have information on, or at least claimed information in literature about the elevation of Blackpool Tower.
Yeah, we do.
The height
of course we do.
Yeah. And what
is that all of the it is. Well, he doesn't. He can't remember ever being Morty Master or any of those other characters that he sounds exactly
Welcome
like.
back. Right?
Yeah. So I mean, it's below, right? Even Blue says, I don't know how many feet down. But that's obviously what they're doing.
What you're saying is it's obviously lower.
Yeah.
Right? And you're asking.
Are you not saying it? Do you not think it's lower?
How you're asking the question? How do you know it's not lower? And I would say, well, how high it is, you would know by the elevation information. So what you're implying is that elevation information is wrong?
No, I'm looking at what Blue's doing with this brand new Blue Marble armchair geodetic surveying, right? Where they take a picture of they got off the internet, because there's a camera strapped on the back of the auto level, and I think you'll hear us say many times that invalidates the tool. But I mean, okay. they never listen. But this is a new Blue Marble geodetic surveying technique.
Yeah, well,
yeah, and they make sure that Blackpool Tower is definitely below, right? But how do you know it's not just below? You need to do a reciprocal, don't you? To check. That's why we're going to Bedford to do the reciprocal rumpus pole sighting. To make sure that the drop occurs both directions. A reciprocated drop.
Okay. Okay. Thanks.
Thank you. Mike Jones says, Blue imagines you're 50 foot tall, Bev. Thank you very much. Yeah. Well, I'm only little. I think they all know that.
You can put it both ways. Or Blackpool Tower is, let's say, as small as you, or you are as big as Blackpool Tower. So, or you have like 50 foot, or Blackpool Tower is, let's say, 5 or 6, or whatever height you are. So you can have both ways. But this is just misrepresentation of perspective.
Have you noticed the one of the laws that he's not breaking, the stolen concept? You might not be noticing it because he's doing a good way of tricking you with it. But it's still in there. Shout out if you hear it, see it. There we go.
That's horizontal, that's level, and they're not the same. Predicted drop is about 95 feet. And
95 feet drop. Everybody knows what drop is, right? Down, below. You have to fall in order to get a drop. Unless he's talking about a rumpus pole. But again, I'm not too sure. Hard to tell. But he does say 95 foot drop down, below, like Jesse Kozlowski says. We haven't reciprocated it, so obviously. Since we were there, right, to show people that over 500 meters, you can't measure an angle of an arc second. Can't see it. An arc second in that picture is 3 millimeters. Could you measure to that as your tolerance through those sights? Do you think you really could? With an auto level, it's got better scope than the guy that lied about measuring angles at that accuracy. That's what we went there to go and show people, and that is valid to be able to show people through an optics thing, to show people what you could see through these optics. That's why we put a camera on the back of the auto level, not to actually do any surveying with it, just to show people. But 95 foot, well done, Blue. Nicely done.
That's just about exactly what we see there.
That's exactly what we see. Okay, let's see how we do with the excuses.
So now for the excuses. Well, I know what Bill's going to say. He's going to say they were just taking a picture of the measuring rod and the tower happened to be in the background and mean old Blue's not playing fair.
I don't know about playing fair. Just wondering why you're doing it, but I don't know.
Or he's going to tell us that the auto level has a maximum suggested working range, which is true if you're trying to read a measuring rod, but we're not trying to do that.
No,
what I'm doing is looking at where it's striking that building in the distance.
Yeah, he's imagining Blackpool Tower as a rumpus pole, I think.
Yeah, strange.
Yeah.
This is strange.
Like I say, this isn't like Blue says, right? It's got a working range. We're not dealing with that tool, right? We're extending the range with the new Blue Marble geodetic surveying, armchair surveyors. It gives you an ability to use objects in the background to be able to do this.
Actually, what it boils down to is reasons.
Reasons.
So what conclusions can we come to? Level clearly and measurably deviates from horizontal over distance, and it does so at a rate of 8 inches per mile squared.
That's what Jesse Kozlowski said. Drops down, drops away from horizontal at a rate of 8 inches times the distance in miles squared. That's Jesse Kozlowski's words. Blue's just parroting that.
We've proven that.
Well, I wouldn't say proven.
This effect can be confirmed both qualitatively and quantitatively.
Whoa, this effect.
We've just shown you that.
It's an effect now. That's not really fair. That's a bit of sophistry, right?
Yeah, visual effect. Yes. So now he's talking about a perspective. So
he said he's
visual
proved it,
effect.
but now it's an effect. How can you prove an effect? I'm not too sure Blue knows what he's talking about. Maybe a slip of words, right? Maybe he said the wrong thing. Maybe one of his intentional mistakes. Who knows? You never know. He does leave a lot of mistakes in so everybody can find them.
And Bev's assumption that level is horizontal is absolutely false.
It's not an assumption, Blue. It's not an assumption.
So I got one final question, Bev.
One final question.
You still think this was a good idea?
Absolutely.
Hey, thanks for watching.
Yes.
And that should do it.
Okay, so that's Blue Marble's video, right? So Blue Marble's prepared that, and that's his argument against all horizontals being parallel, and that level is ... Like I would say, he's saying level is not horizontal. It's not really a much of an argument, right? To say, it sounds like he's saying nuh-uh to anything I say and waiting for my arguments, but
his error is within this picture, which is present on the screen right now. Because on the screen we can see that you are, let's say that you are nearly exactly between middle crosshair and bottom crosshair.
Yeah.
And Blackpool Tower is nearly exactly between middle and upper crosshair.
Yeah, at least the metal structure.
Yes, but let's get rid of that and let's say that your height is in this picture the same as Blackpool Tower.
Yeah, I think me is like 340 foot, I think.
Yes, so and he is measuring that drop using absolute measurement of the picture. So he's ignoring perspective because he's measuring that drop from Blackpool Tower position, it would seem. So he is applying.
You can't measure, right? That's the problem with this.
Yes. Or calculating. But this is better word.
Yeah.
So he's calculating this drop of the level. But ignoring perspective, so he this difference between you and Blackpool Tower, of course, is huge, but he's ignoring that in order to prove that his point of this dropping level. So he's just confusing measurements of the things in perspective, because in fact in perspective and I am marking my words, centimeters or feet are getting smaller in perspective, not in reality. In reality, they are just the same. But in perspective, in picture, if you have a height of 10 centimeters and you are moving away from that, these centimeters are getting smaller, are shrinking.
I think you can all you've got to do is look at that picture.
Yeah.
I'm about the same as Blackpool Tower. In proportion, like in between those things. Like you could just look at it and say Bev's about the same time as same size as Blackpool Tower.
Yeah.
That's it. That's all you need to say.
Quick question. How far away is Blackpool Tower in this?
No, it's just in the background. What we're doing is we went there to show that you cannot measure to an arc second over that distance because some lying dude had fooled everybody and told everybody that he could measure that angle over that distance.
The Blue Marble didn't say it here though, right?
No, Blue Marble didn't say that he was measuring. When we went there to do that and that picture was taken, right, from that video, we were going there to show people that you cannot measure to an arc second over that distance.
Okay. I would love to see that claim. I've actually not seen that.
Well, you have a look. It's called, there's a dude, what was he called? I think he lives in May, probably doesn't live in Maine, but he made a video where he wrote down some numbers in a book and then claimed that he'd measured plumb lines not being parallel. Right? And we said, nah, we don't know about that. But what we do know is that you're a lying shit and you didn't actually measure that because it can't be done. And then we said, I tell you what we'll do. We'll go and show everyone exactly how it can't be done. So we did. We put a camera on the back of the auto level, went out to Southport Beach and put a nice big backdrop. Like it was popular at the time. There was a guy who found a picture on the internet taken from similar sort of place on that beach of Blackpool Tower and the mountains behind it. So it was a bit hot at the time, right? We thought it might be popular and people might want to watch it because, that picture was popular. Turns out, though, that they didn't really want to know about this guy that's been lying to him for ages. A protege of, what's he called? That guy that fucked off. Jesse Kozlowski, right? It's a mate of Jesse Kozlowski's and Larry Scott. It's a mate of Larry Scott's, yeah. Lion shit, we call him. Oh, no, sorry. The guy that may or may not live in Maine that's a lion shit. Yeah, him. I think he's done a Jesse Kozlowski. I don't think he's going to be coming back again.
So, are you talking about a YouTube channel called The Main Surveyor?
Well, yeah.
Okay.
Yeah.
And he made the claim that he was measuring a vertical angle to an arc second.
Yeah. Over 500 meters.
Over the distance that the Blackpool Tower is there, or over the distance
over
that
the distance that I was at with my measuring rod. One arc second over that distance was about 3 millimeters. So if you look in those pictures that Blue's got plenty of, see whether you can measure to 3 millimeters on the measuring rod, and you'll know whether you can measure to an arc second, won't you?
Okay, I see. It's interesting, yeah. Well, I still would like to see the claim where he's saying that he was doing it to an arc second, measuring to an arc second.
Watch the video, right, where he writes down a load of numbers in the book. You don't actually get to see him measuring anything, but he writes them down in his book, right, to the arc second. And in fact, he goes to fractions of arc seconds as well. Like just to go a little bit better.
How would you expect him to show him measuring? Just a third camera that shows him looking through the thing, or
what do you mean third camera? You don't get to see a camera of him looking through it at all. He just writes some stuff down in pencil in a book.
That's what you would have liked to
genius.
see. That's what you would have liked to see, or
no. All I would like is an acknowledgement from people that he hasn't done what he's claimed that he's done. But still, people post his videos and say, like, "Oh wow, isn't he great?" But they don't actually realise he's lied to them. It's sort of a debunking thing that we're doing at the minute.
Okay.
Mm-hmm.
Yes. I'm gonna try to find the
it's all right. Morty Master hasn't got a clue what he's talking about.
It's quite it's a very vague description you're giving. He's writing a bunch of numbers in a book.
Yes,
it's very specific.
Lied.
That content.
Yes.
So,
thanks for bringing it up.
Writing a bunch of numbers in a book does not really imply directly.
It doesn't get anywhere to give a proof that plumb lines are not parallel, though, does it? Right, because what we're dealing with, Morty, what we're dealing with here is a claim from Blue Marble Science that people can measure angles to say that plumb lines aren't parallel. Blue Marble's just done it, right? Now, all we're pointing out is we've been out there on the beach to prove that it can't be done. These angles can't be measured to the accuracies that people are claiming they're doing it. You can't cite to that. You do understand that, right? So when you spot that somebody's lying to people, would you expect people to sort of say, you know, here, look, have a look at this. You're being lied to.
Yeah, no, that's fine. That's fine.
Are you okay with being lied to? Or are you okay with your friends being lied to?
Depends, but no, in general.
No. Okay, so it's a good idea then for us to point out something that you should really be looking into.
Yes.
Right, okay. Now let's say if somebody was pointing out that thing, would you go, "Oh, look at Blackpool Tower in the background"? Well, forget about that guy who did the thing and, you know, like, forget about him. But let's look at Blackpool Tower in the background dropping. Because Jesse Kozlowski said that level has to drop away from horizontal. So Blackpool Tower must be dropping away in the distance.
Well, you said yourself that you chose that location for the backdrop because it was popular at the time. So it does seem a tad more reasonable to actually look at that.
Is it?
You were saying yourself that it was kind of hard at the time when you did that.
Yeah, what's the point in this? Are you going to get to any sort of actual point? Or just point out that it was a good idea of us doing it?
There's people, look at Blackpool Power. What was your point?
Okay. Yeah, the point was, look at how this guy has lied to everybody. But nobody really cares. Because I think within this little arena, this paracosm that people have generated for themselves, they expect people to lie to them. I think it's part of the custom. Lies.
Yeah,
and they're accepted lies. Contradictions, fallacies, all of that sort of stuff. It's sort of liked within this arena. Sophists love that sort of thing, don't they?
I guess you do, yes. So expecting to be lied to would be a sort of a source of skepticism, right? If you're conscious about it, if you're knowing.
No, we're just pointing out the lies. We're debunking. We're extracting the bullshit and showing it you.
Okay.
Yeah.
Okay.
So what Blue is doing in his presentation, because this picture is in Blue's presentation. So instead, Beth was taking that picture to show that this Larry Scott and Jesse Kozlowski, and they were in this presentation. He presented their alleged measurements from a great distance, and this picture which originally was presented by Beth to prove that they couldn't do that, what they allegedly did, and Blue Marble Science and others, they are using that picture not to confirm that yes, that would be bullshit, but they are talking about Blackpool Tower drop instead. So this is just hilarious. So they are just closing eyes.
Yeah.
Instead of addressing the point that we
everyone
cannot.
else in the arena, much like you, Morty, you're helping them, right? You're being an apologist.
How?
How?
How so? Yeah.
Well, what are you coming in here for? What's the point of you being here?
What? I was just interested what you're talking about, what you're presenting.
Okay, so are you interested in the fact that we sort of proved that Jesse Kozlowski, Larry Scott, and the main surveyor can't make accurate measurements that they claim they do? And since their numbers are farty little parts of angles that you wouldn't even be able to notice, there could possibly be some sort of a mistake that might be worth looking into, right?
Yeah, I'm very interested in finally getting the context of why you went there and took those pictures. Because I've seen this is not very new, is it? Right? This is a relatively.
It's an old video. If you come to stall it, is there something in a bit on the video you don't want anybody to hear?
No, all good, all good. I'm not stalling at all. I'm just pointing out that this picture has been around for a while, right?
Yeah, nobody
And
really gives a shit, do they? I mean, how many times have you seen Larry Scott post that picture of his claiming he's done some weird shit? How many times have people posted the video for the guy who probably doesn't live in Maine, the one that's done a Jesse Kozlowski? How many times have you seen Jesse Kozlowski's lake been posted? Even though he's not around. I mean, I bet it's quite a lot, isn't it? And I bet nobody said, you know, over those distances, you can't really measure to those accuracies that they say that they are doing. You know that, right? I bet nobody's ever said that, have they? Even though we've been out there on the beach to show everyone exactly that they've been lied to by people. Only a few shadow giants. They're not around anymore, but their shadows still linger. Like a really fucking stinky shit. So do you want to do a bit of defending? Blue Marble Science? Because it's all geometry, isn't it? Especially this, when you're dealing with drop. Measurements and stuff.
do you mean with defending?
Defending? Yeah.
What is there to defend?
I don't know.
To defend that horizontal, that level is dropping from horizontal.
Well, the statement was being made that this is a perspective. This is an effect due to perspective, right?
Is that what you think?
Well, that's why I've been asking if we know how far Blackpool Tower is away from the observation point here.
It was said, I think, that it was like 13 miles
Does
or whatever.
it matter to you?
In order for me to deduce
Blue Marble surveying, Blue Marble geodetic surveying, obviously.
Was this a rhetorical question you just asked?
But I'm just wondering, what are you going to deduce?
Okay. If you're genuinely wondering that, why are you interrupting me while I'm speaking about that?
Because I'm just hoping that you're going to make a point about telling us what you are going to deduce. So now that's clear.
Okay.
Please Off you go.
You're starting to ask a question again and then starting to talk as soon as I try to answer your question. That makes me extremely skeptical if your questions are genuine in the first place. It destroys rapport, Beth. So yeah, it matters. The distance to the tower in this observation matters for me to deduce the explanation if perspective is a sensible explanation for what we're seeing or not. Like we can just plug some numbers in and see if that makes sense.
Okay, so but I think that if you heard previous part of presentation, what Larry Scott and Jesse Kozłowski did, they measured angles through theodolites. So we have in this picture, which is on the screen, we have auto level and crosshairs. Of course, we can say that there is some angular size or angular distance between middle crosshair and upper crosshair, and the same angular size would be between middle and bottom. Do you agree with that? That they are the same angle? They have the same angular size, this distance in auto level. Can you agree on that?
Yeah, sure. I'm.
Okay.
I think that probably is probably right. Yeah.
And it means that Bev in this picture has the same angular size as Blackpool Tower, excluding this
Yes.
antennas, whatever it is.
Roughly, yes.
Yes, but it means if you are equivocating, measuring angles with real measurements with measuring rod, you can easily fall into error, because from that picture, that would mean that Bev is the same height as Blackpool Tower, because they have the same angular size. And obviously, it is paradoxal, because we know that it is not true. But still, okay, go on.
Organist, the thing is that this, due to perspective, this sort of that Bev appears the same angular size as Blackpool Tower. The head of Bev, if it's above eye level, if it's above our line of sight, will not shrink, and he recedes on a horizontal, will not shrink below horizontal.
If I walk towards the auto level, my head will be above it. So you've just ruined yourself right there. I don't know what you're doing here, Morty. You shouldn't even be here.
That's probably because you're standing lower than the auto level. Because if the auto level is not is lower than you in elevation, then you have to be standing.
Look,
we've put not as high as you.
We've put a camera on an auto level. It's not valid for any surveying purposes.
Sure.
It's only valid for optics, to show people what you can see through the optics of the tool, not for any surveying purposes. I'll say it again. Okay. Now, Paper just did an angular size thing with you, right? I'm not so sure he was quite right, because it's an auto level, doesn't measure angles.
Yes, but
it shows where eye level is, right? The horizontal, it shows the horizontal.
Sorry, my point was that by measuring angles with objects which are in completely different distances, you cannot compare them. You cannot just compare.
Just compare
Because-
comparative sizes of the things. You don't. There's
Yes.
no need to put angles there. There's just, you can see that I'm not the same size as Blackpool Tower in reality, right?
Yes, but on the picture it seems like you were. That's the problem. So that's why my point is that you cannot just use angle, size of an angle to measure things, because you cannot compare sizes of objects
Auto
using.
levels don't measure vertical angles.
Yes, of course. But even if you would use Theodolite, as allegedly Jesse Kozlowski and Larry Scott, they did allegedly. So this tool can measure angular angles, so angular size also. So it means nothing in that case, because if you are measuring objects in different distances, your measuring angle gives you nothing, because it is not comparative. You cannot
an
compare.
auto level. Can we please stop using measuring angles or anything? Like, there's a measuring rod in the picture. Can you measure anything on that?
No, of course. But
so nothing can be measured.
Yes, but I am referring to this Larry Scott and Jesse Kozlowski. So you cannot see anything, and you cannot even measure angular angles.
But they've wrote them down, right? There's some numbers wrote down. Blue took them, added them together, and took 180 degrees off them. Minus 180. So, I mean, that's just like the guy that probably doesn't live in Maine, when he was writing his numbers down in pencil in his little book. It's the same thing. It's just people writing numbers down in books.
Yes,
but that's how you take readings, right? You're looking through a thing, and you can't just take the camera.
How do you know you're looking through a thing? They're just writing numbers down in the book.
Well, that's a matter of trust, honestly. Yes.
Yeah.
Because in order to,
so you've got a lot of trust, right?
Well,
in Jesse Kozlowski, Larry Scott, and the main surveyor, you have got a lot of trust, because we're showing you that they can't make those measurements, right? I'm showing you that. You can look for yourself to imagine how hard it would be to measure those angles that those guys are writing down. Yet you still have trust in those people.
Well, that's something you are assuming. I have not expressed any kind of trust.
You don't have any trust in Jesse Kozlowski, Larry Scott, and the main surveyor, then, do you not?
I'm not inherently trusting them, no. Why?
Do you know anybody else that's done this?
I don't know anyone personally, no.
No. Just those few people they're the ones that have done this.
What the fuck?
Yeah. Did you not know that?
Okay.
There's only like 2 or 3 people that have ever done any of this.
What is your point, Bev?
My point is that some people are claiming to be able to do things that you can't do. And you have got a lot of trust in those people.
No, I just explicitly told you that that's
you don't
not
trust them.
True. That's not.
Be wise, right? Be wise.
So, yeah.
Yeah.
So your point was a perceived assumption, an unsubstantiated assumption you had about me. Okay, good for you. But now, originally, I was asked the question of what I think about the statement of perspective. That was besides the point of why you took this picture. And
no, I don't give a shit. I don't know why anybody bothered asking you about perspective.
You asked that.
No, I didn't ask you anything about perspective at all. No, I didn't.
No,
yes,
I was talking.
I didn't.
Then you interrupted me when I started answering.
You can.
That's why I told you.
See you later.
Hey, you interrupting me while I'm answering you.
Oh. There you go. Right, that sounds much better, doesn't it? Everybody does know Morty Master. We've just lost 10 viewers when the moment he came in. You can hear people go like, "Fucking hell, no, not him."
Thank you, man.
He's got fucking nothing. Absolutely useless. And imagine him sending him in. I suppose he would get some extra credit points for it, but he's useless. Blue Marble should be coming and doing this for himself, right? But this is the point that I wanted to get to. We have to forget that bullshit he's been talking about. We are now on... I've given 2 arguments, and Blue Marble's done his video. Okay. Here we go. This is where we go to next. I just wanted a bit of comeback from Blue Marble, but appears that's it. Nice. This guy's here. Thank you very much for that. Do you want to go with your rebuttal to my presentation of the arguments first?
Oh, let me see. I'm trying to get the windows fixed back up here again. Oh, I know what I need to do. I need to get rid of that. Bear with me for a second. I'll figure this out. How do I get Discord back on? I want to be showing that window, but something is not right. I'll tell you what, while I fiddle with this, why don't you go ahead, Bev?
Why don't I go ahead and rebut yours?
Yeah, you want to do that? Or?
Okay, yes. Your final question, do I still think this is a good idea? Well, you asked for it, and yeah, I'm thankful that you've given us the chance to do this. I think this is exactly what this arena needs at last. Because we have been talking about what we call existential cognitive veiling. Now, that is the idea that people don't want to talk about certain topics and certain things because of the realness of the thing. And level and being horizontal is one of those things that most people are normally shied away from. Not many people have even thought about the consequences of that. I mean, it's pretty simple from hearing what you say, that there is a problem within the model that you said. I think you said something about it can't be, right? Like a model dictates type thing, that it's not allowed. And that is the fact of the matter is that really you can't have a horizontal plane. Like what everybody understands as a geometric horizontal plane with 0 slope on it. Well, that cannot exist on your model. Now, I'm not bringing a model into any of this at all. The idea was to talk about all horizontals, which obviously are a geometric concept, but obviously it brought into reality by being parallel to the plane of the horizon, linking the horizontal to the horizon. Now, when you showed that, you seem to have horizontal planes intersecting a vertical, and they didn't look perpendicular, which like sort of breaks the law that vertical and horizontal are perpendicular. I mean, that's everybody knows that vertical and horizontal are perpendicular. Therefore, to sort of show a picture where they're not, and like sort of say that, well, your model dictates that has to be true. So therefore you can imagine a horizontal and a vertical not being perpendicular to each other. I mean, it sort of allows the within the logical formula of a reductio ad absurdum, where you could say, take it to an absurdity and say that horizontal and vertical could be parallel to each other. Going with the rules that you've just stated, which, I mean, that's an absurdity, but I'm guessing that's where you are, right? You're in the land of absurdities and contradictions, whereas I just don't do that. I go with the geometric understanding of vertical and horizontal being perpendicular. And I assume no other shape of anything to dictate anything within that framework. It's just a purely geometric understanding of, obviously, a vertical is a straight line. I mean, nobody's going to deny that, right? And because a vertical is a straight line, a perpendicular is a relationship of a straight line in, you could say, maximum opposition, but in order to make all four of those right angles, Euclidean axiom again, all right angles are equal. So all four of the right angles are equal, making it that those two straight lines that are perpendicular to each other form those four right angles. And that's always the relationship of vertical and horizontal. So it's also within the definitions of Euclid, which I noticed you did use a bit of Euclid in your proof. I commend you for that. I think it's well worth pointing out to everybody that the logical arguments that are formed within Euclid are worth using within a debate, because it gives you a definitive answer. It's just that your fallacious reasoning in using that that was at fault. The relationship of the perpendicular is within the definition of book 11. Let's see if I can just get it quick here for you. Book 11 definition. A straight line is perpendicular or at right angles to a plane when it makes right angles with every straight line meeting it in that plane. That's a definition. So a perpendicular to a plane is perpendicular to the plane anywhere where it meets any of the straight lines within the plane. Not at a certain point, at least geometrically. And that gives you the horizontal plane for you to build from. And at every point on that horizontal plane, you can have a perpendicular, and all of those perpendiculars to that plane will be parallel. So the issue I think that you've got before you is the horizontal plane, which is only perpendicular to the vertical. So I mean, if you have the vertical, then you can have the horizontal plane. When you have the horizontal plane, you can have all perpendiculars to that horizontal plane will provably be parallel. And that's, I guess, that would be my rebuttal to what you were saying. I mean, you've got, obviously, Larry Scott, was it? Larry Scott and Jesse Kozlowski, some shadow giants that say they've measured angles. Well, we have a test called the Realizing Euclid test that is to show that no straight line can belong within the plane and then without it. The straight line lies within the plane. So that would be my presentation to you, to see the Realizing Euclid test and how the horizontal plane obviously can be established. I mean, it's talked about often. It was talked about within the contour lines of on maps. It's a horizontal plane, or as in all of the maps are. They're made and formed on the horizontal plane, and the contour lines are depictions of these other horizontal planes as slices through the terrain elevation. And also every elevation profile ever drawn will start off with a horizontal baseline, and then you will have a measured vertical as being perpendicular to that horizontal. So all of the horizontals within every elevation profile of every engineering project or anything that's ever been drawn, all of the horizontals will be parallel within those pictures and drawings also. And I would offer you contour lines on maps as well also. Are you ready to?
Yeah, sure. I just want to make sure you say everything you want to say.
I'm not too sure what more I could say, really. Okay, so what does everybody think of that rebuttal? I know it gets boring. People are leaving. Who wants to listen to Blue Marble and shit like this? Me. Because Blue Marble says some good stuff.
I do, but I'm doing an oil change right now, so I can't really talk.
Rams put, can you explain why an observation made using an auto level beyond its valid distance, and which you say can't be used to measure an angle, vertical angle, proves that it's impossible to resolve that angle? Surely it only proves it's impossible using an auto level. What we did, we've got some genius mathematicians, and they do like to do calculations. What we did was, you get a distance of 500 meters, call that a radius, and then you measure the angle difference of what 1 arc second would be as a linear distance, as in a travel of a radian around the circumference and that sort of length. And it's 3 millimeters. So all you have to do is to see whether you can measure anywhere near 3 millimeters. So like if you could measure from 3 millimeters to 6 millimeters, you know, with there, if you could see it, then you could measure it, right? You'd easily be able to measure that angle from 3 millimeters to 6 millimeters. You'd be able to start at 3 millimeters and go to 6 millimeters. That's how you would be able to see if you could measure that angle. But if it turns out you can't even see like 10 centimeters, then you'd have to say that you're never really going to get to 3 millimeters accuracy, right? Which would be to the arc second over that distance. Thus proved. And also, my auto level's got fantastic optics on it. It's like some of the best shit ever. And it's a 32 times scope. We know for certain that the guy that probably doesn't live in Maine, has only got a 24 times scope, and I think it's a 30, or it may only be 28 times. We do know that it's not 32, right? We know that. So he hasn't got as good optics as we have within the auto level. And obviously, he can't strap a camera onto the back of his thing to show anybody what he's actually doing and how he can measure those angles, because he can't actually do it. But he can write them down in a book. We're the ones that go out and prove that you can't do it. And we streamed it all live to Discord like we do. All the time. So you could have actually been in here, come in and watched it. We did it over at Geo's. I think it's still out there. I don't think I ever even got it for myself. I don't think. I think it only exists out there on the Earth Awakenings channel. I don't know if anybody else has ever done anything like that in any other channel. It may just be us that does this sort of stuff. Yeah, I don't know. You're looking at, yeah. AK, so like he's done research. He doesn't use a measuring rod or anything. It's fantastic, these guys, right? So do you want to hear like Blue's rebuttal to a rebuttal, or whether he's actually going to have a go at rebutting either of my arguments? Let's see what Blue does.
Well, let me see if I can go through a little bit of it. One thing you talked about was that you think that I didn't draw horizontals perpendicular to verticals, and I can probably almost guarantee you, because I did that. I didn't do that in a CAD program. I did it on PowerPoint. So maybe my eye is not as good as I thought it was. Maybe I got them a little bit out of whack. But in every case, in every single case, I fully intended to make sure the horizontals are perpendicular to verticals. That's the definition of it.
Yeah, but it was when you extended it.
When I extended,
are you doing the rebuttal to my rebuttal, or are you doing your rebuttal to my argument?
Well, we can just go from there at this point. What I would say, though, to kind of start it off, is you've got nothing but pure geometry, and you have failed to consider.
So you might have just heard, whether you picked up on the sophistry, but Blue's not going to rebut any of my arguments at all. He wants to go into his thing. It's a fancy way of debating this. Blue makes a video, presents a video, and then just talks about his video.
Consider a possibility of a different geometry. You've done nothing to look at what would happen if the Earth actually was spherical.
Well, see.
On the other hand, I made no.
Did you hear that?
Kind of started off as you've got nothing but pure geometry, and you have failed to consider a possibility of a different geometry.
You've got pure geometry, and you've failed to consider the possibilities of another geometry. Yeah, there's a reason for that. Because Euclidean geometry is what you used as well, Blue.
Yes, exactly. So he's referring to non-existing thing.
Yeah. Like what? I want to fantasize with you, Blue, about something that couldn't possibly exist outside the realms of proof. Let's step outside mathematical realm into fantasy. No, Blue, we're sticking reality. It's fucking stupid.
Nothing to look at what would happen if the Earth actually was spherical.
Well, see.
On the other hand, I made no assumptions whatsoever.
Well, yeah, I did make an assumption, right? Assumption number one: a vertical is a straight line.
That's okay. Make the same assumption. A vertical is a straight line.
Horizontal is perpendicular to it, right? Okay. Yeah. And horizontal is a plane.
In every case, horizontal is perpendicular to vertical.
Okay.
In every case.
And all perpendiculars to the horizontal plane will be parallel.
To a horizontal plane, not to all horizontal planes. That's the problem.
No. All perpendiculars to a horizontal plane will be parallel. Yeah?
That would be true, but only one of those verticals is a plumb line.
No, perpendicular to horizontal.
Every other vertical line perpendicular to a horizontal line, except for the one that's a plumb line, will not be plumb lines.
It's a special plumb line. That's perpendicular to a horizontal plane.
Yeah, so he's making a baseless assertion here. That different plane would be different because...
He's not saying different plane. He's saying on any horizontal plane, there will be only one perpendicular that you could call a plumb line. All of the rest will be called verticals, but you will not be able to call them plumb lines because they are perpendicular to the horizontal, vertical, but not plumb lines. He's separating vertical and plumb line. Now, even though it was in his rules that they're the same, he's separating them. Just one.
Yeah, so he's at least inconsistent.
Yeah. Yeah. Nothing if not inconsistent.
They will
no, but
be
they
leaning.
They will be vertical.
Just as we
right?
just showed you.
You said that vertical and plumb lines and zenith and the vector of gravity are all the same.
That's all the same. Exactly.
They are all the same, right? So vertical can be the term that we use. Now, perpendicular to vertical is a horizontal plane. Would we agree on that? At least
if you're going to call
if you're going to
call vertical, if you're going to call vertical a gravity vector,
you did. You agreed.
Okay,
to
that's what I'm calling it too.
Yeah. Okay.
Then we're going to go back and sort out.
That's a straight line.
The disconnect. We're going to sort out the disconnect here.
Okay.
In reality, vertical is a plumb line, and there's one and only one of those associated with a horizontal. Every other vertical defined as a gravity vector is not going to be perpendicular to that horizontal line.
There you go. You can only have one vertical perpendicular to a horizontal. Geometrically. Blue marble science. I mean, it's been done quite a bit ago, this. I'm not too sure that people are aware of it, right? Like people not being aware of the fact that you can't measure angles that certain people claim that they have done, especially over massive distances, right? It gives people the idea that they can take a picture taken through an auto level and perform miraculous blue marble surveying techniques. Like blue marble, right? At least you get to sit in your armchair in your house and just like analyze a picture. Whereas actual surveyors actually have to survey locally, right? Measuring angles and doing all that sort of stuff. Not these guys. These guys can just look at pictures and maybe find a few pixels or something, do all that sort of stuff. Blue marble science is explaining now that there is only one vertical per horizontal line or plane. Okay, that's where I started. Like saying that you have a vertical that's a vertical that's intersecting that horizontal plane, not perpendicularly, don't you? In fact, you have more verticals, i.e. plumb bobs, that are intersecting the horizontal plane not perpendicularly.
There are an infinite number of them that are doing that. There are an infinite number of plumb lines intersecting a single horizontal, which is only perpendicular to one of them.
But all vertical. So he's got blue marble science. I have to point out this, right? For each horizontal plane, there are many verticals that aren't perpendicular to it. In fact, there's more not perpendiculars verticals to a horizontal plane than there are in blue marble science's dogmatic globe model. I mean, you would have a struggle trying to convince anybody of this shit. I mean, I suppose people like blue marble science and AK and anybody else that comes over here listening to this, this is the only place that they can come and practice it, right? Because they'd sound like fucking crazy people anywhere else. But they think they can come over here and tell us this stupid shit. Whether it's a troll or something, I don't really know. I'm not too sure whether they could actually be serious saying these sort of things. And where else could you say it? How ridiculous is what Blue Marble's actually saying here? And where could you actually say that sort of stuff other than like walking around a mental home? Just talking, rambling to yourself. And horizontals are perpendicular. At least that's the understanding, right?
All verticals have their own horizontal, Biv.
No.
That's the problem.
Nobody says that, Blue. People say vertical and horizontal are perpendicular. That's a statement that you can make, right? With no queries or anything, right? You just say that vertical and horizontal are perpendicular. There's no qualifications. There's no special rule to that. They just are. Sure. In reality, anyway, surely.
Let me know when you're done.
Go on.
Let's make sure we're clear. When I said vertical, when I said vertical a while ago, when you were talking about to a horizontal, yes, you could have verticals too. You could have an infinite number of verticals perpendicular to any particular horizontal, but only one of them will be a gravity vector. Only one and only one.
Again, he's got them all being the same. Yet he's just separated it, and now he said there's only one. Nothing if not inconsistent.
Now, the problem is that you have assumed that there is one and only one plane of the horizon. And the fact of the matter is...
He's literally just told me that there is only one plumb to a horizontal plane. And now he's telling me that I assume there's only one. People can see what's going on here, right?
Yes.
I hope Blue Marble can see what's going on.
It's like reversing argument, because you are talking about plane and he is talking about only one plume. So, of course, to one plume, you have you can have only one perpendicular, because perpendicularity is one. So, but it is from his argument that plume is only one, not from your. So he's just, I think, flipping argument here. I don't. Doesn't make any sense.
He's handing off his argument to me, then he can argue against me instead of me arguing against him. I call it sophistry, obfuscation. But I mean, it works well for many people, and there are people out there that will be praising Blue for this. He's cheering squad. It's probably Wally and everybody else that's coming in here tonight to come and help him.
There is an infinite number of them.
We're talking about the horizontals.
There are an infinite number of horizontals. If you define horizontal, it's perpendicular to the gravity vector. There are an infinite number of them. If you move your instrument, you've got a different horizontal. Even if you just move it an inch, you have a slightly different horizontal. And for sure, when you move it 10 miles, you've got two very different horizontals.
Horizontal is a straight line with zero slope, right? It's a plane with zero slope to any corner.
Do you understand that the reciprocal zenith angles show you that the horizontals have to be not parallel with each other?
No, there's no tilt to a horizontal.
Yes, there is. It's measured.
There's no tilt to horizontal. Do you hear that?
Yes.
There's no tilt to a horizontal. He says, yes, it's measured. Listen to it again.
That the horizontals have to be
there's
not
tilt.
parallel with each other.
No, there's no tilt to a horizontal.
Yes, there is. It's
no,
measured,
there's no
Bev.
tilt to horizontal.
I'm sorry.
Yes, there is. It's measured, Bev. So, anytime the tilt of the horizontal, the measured tilt of the horizontal by Blue Marble Science. See how far we can go. Perhaps we can get a plumb line tilting.
Sorry, you can deny it. Stick your head in the sand and do all that you like, but it's just no. I've got measurements, and it's not just Larry and Jesse.
You've got measurements of a tilting
I showed you the measurements. I showed you the reciprocal zenith angles measured by NOAA. It comes from 1978. We can come up with hundreds, probably thousands of those. Not by Larry or not by Larry or Jesse. Independent sources. This is well known in the industry. It's well known survey.
The angle of a horizontal to a horizontal.
Those horizontals are not the same. They cannot be because the plumb lines are not parallel. We have proven that.
You've proven that there's a tilt to a plumb line now as well.
Absolutely. The two plumb lines tilt away from each other.
There you go. Again. Horizontal tilting and plumb lines tilting.
Yes, so these are two statements, but how they are related to each other.
It's measured. He says he's measured.
But measured means, in that case, that you are measuring this tilt because this is only way how you can somehow logically explain that. You have to measure vertical from different horizontal.
Yeah.
Blue is either dishonest or blue is dumb. And I will reiterate that again. Either lying or he's dumb.
He's measured the tilt of the horizontal. Wally's got some as well. Open out. Difference in angle between two horizontals has been measured.
Yes, so he measured tilting, let's say vertical from in his location from horizontal, which is not in his location.
Yeah.
Because this is so, and this is impossible.
It's the equipotential angle of adjustment, the angle between the orientation in one location and the orientation in a different location.
Yes, but it means that you have to be both in two locations at the same time.
Yeah, it's only Blue Marble geodetic surveyors that can do this. Because you can't, like, you're better off getting the opposite side angle and filling it with the rumpus pole. That's the best bet. But, don't know, Blue Marble's obviously got his own methods. And Wally as well, he's got angle measuring. That most of them do angles. I don't particularly trust the angles. I know how people can be tricked by an angle.
Yes, that's why with this conversation, I was just proving that you cannot even use that measurements of an angle to anything if you operate with different distances and long distances. It's just useless. And by the way, these angles cannot be measured, as you can prove with your picture with Blackpool Tower.
Yeah.
So we have two impossibilities.
Yeah, but these are really good, right? These Blue Marble geodetic surveyors like Wally, they can use some new technology. They've been made for us. It is 2023, right? Science has come a long way with technology and stuff like that.
No, for me, it sounds like this argument with this fiber optic something gyroscope. So just fairy tale. I don't think so. That you can disprove level and horizontal using new technology. This is just absurd for me.
Yeah, a plumb line tilt. Measured, horizontal tilting, also measured. If anybody's wondering, Blue Marble Science and Wally, apparently. Wally says, we are saying one horizontal is not parallel to another horizontal in a different location. That's Wally's we. Maybe all of the voices in his head. Possibly. Or I don't know whether he's got a local
maybe
group.
royal plural or whatever. I don't know. You know, this syndrome of greatness or whatever. I don't know.
And a little bit more. I don't know how much more of this we can take. Blue marbles.
Euclid showed you why.
I'm pretty sure there's no tilt to either a vertical plumb bob or a horizontal, a level. There's no slope, no tilt ever.
All I can say, Bev, is that all the measurements ever made disagree with you. Those verticals,
disagree
those
with
plumb lines.
He said all the measurements ever made disagree with me, like all.
He exaggerated because this qualifier all is just destroying his claim.
Yeah,
he cannot prove that all, because one black swan is sufficient to disprove him. So this is very dangerous what he said.
Well, they do tend to use that, don't they? I mean, he's overqualified himself, but he says all measurements prove that horizontal slope. Yet getting an auto level and establishing an elevation change by measuring a change from the horizontal would surely prove that there is no slope to the horizontal. I don't know what he's talking about. It's ridiculous. It would be very simple to prove that there is no tilt to a horizontal. And if you were ever to end up with horizontals intersecting, you could guarantee that one or both horizontals must slope. Right?
Yes, of course.
It's an impossibility for horizontals to intersect and not slope. But this is where we're at. This is modern day dogmatic globe. Whereas normal people would just have this on their globe. They wouldn't be aware of the contradictions that Blue Marble Science is trying to make people hold. Betty's trying to tell people that they're not rational for that. Blue Marble's trying to tell me that I don't know that all measurements prove that horizontals tilt. There's a slope to them.
Those plumb lines are always diverging, always. There's not a single case where you see the verticals parallel with each other or converging. They always diverge.
See?
Yes, and this is just stupid, because obviously on your whiteboard you have two plumb bobs which are parallel. So it would disprove his idiotic claim.
They're always, what did he say?
Always diverging.
Well, how do you do that? Because you hang plumb bobs from the top. So would they not go together at the bottoms?
I cannot respond because this is just nonsense. So How can you respond to nonsense?
Would you say if you were to hang two plumb bobs and the bottoms were closer together, would you say they're diverging?
Rather converging.
Exactly. But Blue Marble said that they never, he seems to be forgetting this, like the idea of the road up is the road down. It's a basic geometric tenet of logic, really. The same line viewed from different sides could be seen to be one going up and two going down, depending on which end you start off at. Well, same works for converging and diverging, doesn't it?
Yes.
So how could they always diverge when viewed from a different perspective they are converging?
They cannot always diverge. Yeah, this is
it's an
his
impossibility.
model, it is impossibility.
Yeah. So Blue, sorry, but I mean it does appear that you are geometrically illiterate, but as expected. And you're in the heat of a like what we call this a discussion, defending a model. And it's terrible positions people get put in.
Now, we don't do this sort of thing over just a few 100 feet or a mile or two, because the amount of tilt is not, the amount that they diverge is not enough to really get you up out of the noise. But when you go 10 miles away or 20 miles or 30 miles away, then you see it.
See what a tilt. And I don't know whether Buster's around here. Not many people are still around. The model dictates that it tilts away. You can't really see it. Sorry.
I have never seen that.
No. I don't know how he thinks you need to go further away to be able to see something that you're never going to see.
Yeah, if you go away enough, far enough, you cannot see anything.
Yeah.
So how can you see that?
Yeah, it sort of works backwards, doesn't it? But I mean, contradictory shit. It begins to be expected. Tilt of a vertical.
The lines, the
tilt of a horizontal.
The plumb lines are diverging. They're tilting away from each other. In fact, every vertical is tilting away from every other vertical. It all starts at one center point at the middle of the earth.
See, this sounds ridiculous, man. Like if you were to meet somebody in the pub telling you about plumb lines tilting, and I'd imagine he gets very heated about this sort of stuff. He does have a model to defend, and I mean.
By the way, if he's saying about gravity and plumb bob is down, so and this down is center of the Earth, it means that they are converging, definitely.
To a point.
To a point, yeah, of course.
Well, he said they never do that. They're always diverging. So it seems to be a little bit. I mean, unless he's starting off at the point, the all-encompassing point, as we say, the monad.
But you know, confusing up and down, this is normal thing and within that model. So don't be too harsh.
Yeah, especially at that point. It's like really confusing what up and down is there, isn't it? Like when you get to that bit. Proper mind wrecker, that. But verticals don't tilt. There's no...
Certainly they do. With respect to each other, absolutely they do.
Look at that. That's confidence for you, isn't it? Like you said, you wouldn't ever see somebody more certain of something.
Measurements prove it.
See? Prove it.
You can't deny that.
But are they both going to be perfect? Anybody else want to try denying that?
Yes, I can try.
Oh, yeah.
I died. I lost the last 5 minutes.
Deny it anyway. You can't deny it.
Yeah.
Yes,
No,
we
I
can.
deny it.
Yes, we can.
Yes,
Dead
I can.
easily. Like, I'm not having that. That sounds fucking ridiculous. Tilting plumb bobs. Perpendicular to the horizontal plane.
At the instrument, at that point, yes. At that plumb line, yes. Horizontal is perpendicular to it, perfectly perpendicular at that one point.
To both of them.
But
at that one, perpendicular at a point.
Yes,
at that one point.
But if you have two plumb bobs, they cannot be at one point. So they are in different location, and you can see that in different location. And Blue Marble says that it may be even inch, so it is probably perpendicular. Sorry, parallel plumb bobs.
Yeah, if you've got a line A to B, and you put a perpendicular at each end of it, and then call the line AB horizontal, then the perpendiculars at A and the perpendicular at B are parallel.
Yes.
Simple, isn't it?
You can do that with plumb bobs, yes.
Yeah.
Very, very easy.
But only that one point.
No, you could. Perpendicular isn't at a point. No, that's
The
not how
horizontal-
perpendicular works.
The horizontal that is established by an autolevel or a theodolite is reference to gravity. The horizontal doesn't exist. The gravity vector does. Horizontal is something that is derived from the vertical, and it is set to be 90 degrees exactly.
But it's
That's
the,
what
it's
an
the
autolevel
horizontal
does.
plane. You know where all the verticals point to, don't you? The monad. That's why they're that important, right? Horizontals don't point to the monad.
Yes, strangely enough. Yes. Because they are circling around.
They're at a
monad.
point, aren't they? That's all they get.
That's what a theodolite does.
It is literally the horizontal plane that is measured within differential leveling. Yes.
No, it is.
Yes, it's the height of the horizontal
wait a
plane.
minute, Biff.
See, so here we go. This is a point. I hope everybody's listening. If you're any good at the geometry and you want to be a globe savior, you cannot measure the equipotential angle of a vertical, because the only place that can be measured is at the center, and you can't get there. So the only way you can actually measure the equipotential angle is by measuring horizontals and the equipotential angle of adjustment between two horizontal planes. Now, however you want to decide to do that, but it involves you setting up, measuring in the vertical plane, starting at a horizontal, and then measuring down to the other horizontal. That's the angle that you're going to do. You're then going to adjust that angle using similar triangles and do a Al-Biruni backhand trick and move the angle, and then say that the vertical angle of deflection or whatever is that one that you've just measured between the horizontal planes. So, but I don't think Blue's aware of that. Within, obviously, dogmatic globe geometry.
Yeah, an auto level is establishing a horizontal plane of reference. I just explained to you how it's doing that. It references itself to gravity, and that crosshair is set to be 90 degrees to that gravity vector. And therefore, the theodolite, or the auto level, is establishing a horizontal plane of reference. No two ways about it. But in differential leveling, how do you do it? You set the instrument between 2 points, equidistant.
You don't. No, when you do
And
the
you
two
do
peg
that.
test, you don't, do you? When you're
And
checking
you do
it,
that.
you
God,
don't.
Biff, I don't give a crap about a 2-peg test. I'm talking about doing.
Doesn't give a crap about a 2-peg test. Do you hear that? He doesn't care. Even though he said you just have to put it in the middle. And I say you don't. In fact, you're not allowed to when you're doing a 2-peg test. He says he doesn't give a crap about that. Doesn't give a crap about it. That's your check.
You
for
brought up the
making sure
differential.
it works.
Okay, check. Yeah, right. Check. You got it.
Okay.
Yes,
well,
you check it. Let's say we've checked it. Now, what do you do with the auto level? You set it up midway between 2 points.
So he's still going midway between 2 points. Blue. This is probably showing. You're going to have to make up some good stories, right? I'd say Blue's never actually done a 2-peg test. Never actually done a 2-peg test. Because he wouldn't be making this argument.
And you take readings, a foresight and a backsight. You know that. You take a foresight and a backsight, and the curvature to the foresight is exactly the same as the curvature to the backsight. If you've got the instrument set midway between the two measuring rods.
You reckon to that? I know this is a bit technical and surveying, but the curvature to the foresight and the curvature to the backsight, whilst looking on a horizontal plane through the crosshairs of an auto level. Curvature.
And you eliminate earth curve that way, you eliminate refraction that way, and you eliminate collimation error.
Oh, don't do
that. That's the
to
entire
George,
reason why
Blue.
it's done. That's the entire reason, and I've shown it to you. In fact, I can go find it somewhere, but you've seen that before. I've shown it to you before.
There is no tilting verticals and there is no tilting sloping horizontals.
You're denying
there is no angle
saw.
Between a horizontal and a horizontal.
You're just sticking your head in the sand. You're just sticking your head in the sand and denying the measurements that you just saw. Not just the measurements by Jesse and Larry. Measurements by Noah, and we can bring a bunch more of them out.
The shadow giants, Blue. You shouldn't be listening to them.
They're not shadow.
They're not here to talk for themselves.
Well, then, what do you want me to do, Bev?
Well, I don't know. I mean, they've got you to say this stuff that they can't say for themselves, which is really strange because you don't seem to know anything about it. And what you've just said is that perpendiculars aren't perpendicular, which is
we have told
a little bit
exactly
contradictory.
Where those points are. I've given you the coordinates for all the points that were measured. You can go out and repeat it for yourself. Why don't you do that? Why don't some of you guys go and do that?
What? I can measure a vertical and a horizontal being perpendicular.
You can do the same measurement that Larry and Jesse did. I showed you exactly where they were when they made the measurements.
I can't do. He wants, again, Blue Marble wants us to go and measure angles, right? Even though he doesn't even seem to realize that it doesn't work. You can do fuck all with an angle, right? You can't really, unless it's like Blue Marble scientific, geodetic, testing. But I mean, like, if you've got an angle and you can do fuck all with it, and somebody else, your mate, right, Larry, has got his angle, and he's over there going like, what the fuck can I do with this? Nathan Oakley said we could do something with it. And you're going, well, I've got one here as well. I'm not too sure what I'm meant to be doing with it. And they go like, well, I'll tell you what. Let's put them together. Right, then... obviously, right, you might not be able to do fuck all with an angle. But if we put both of them together, well then we can minus 180 from it for some reason and end up with a little farty angle. Like, they both had pretty big angles each to start off with. And then they add them both together and they end up with a little farty one. Like, unless somebody walks away with the 180, right? They walk away with it. And the other one's left with a little farty bit. And that might be what Blue's got. He might be picking up these little farty leftover angles that somebody else has done something with. But I don't know how to fit it into a logical argument. It just doesn't make any sense. To me, there's no geometric logical procedure to go with it. To me, now I don't want to say, but I mean, and I pretty much know for a fact that the people that you should be asking have fucked off. They're literally not here. Jesse Kozlowski and the guy who probably lives in Maine knew fuck all about anything anyway. He wouldn't be able to answer any questions. The only person really that's around is some crazy old dude that told my son that triangles have more than 180 degrees. And it seems like he's added that a little bit extra to his straight line as well. Similar, isn't it? The fact that they minus 180 because it'd be like a little bit over 180, which would look like a triangle with some extra angles. Maybe. They're trying to hide all of that sort of shit, but who knows?
Do it yourself. Well, you can't, but somebody here in this country, get one of your buddies.
We do tests, Blue, but you just misrepresent them. We have actually done stuff. We went over one the other day, that you have avoided answering any questions about.
What was that?
When I walked out on the beach towards the horizon, the true horizon over water, and I managed to get myself underneath the horizon. I mean, how's that possible?
Well, you're talking about the tree line. Yeah.
The what?
That horizon was a tree line, Biv.
No, it wasn't, Blue.
Yeah, it was, Biv. Pull it up. Let's look at it. Pull it up and let's look at it.
What you want to see under the horizon?
You want to show it to us again? What I saw looked like a tree line.
Yeah, but it's not. It's the true horizon, Blue. The true horizon. You know what the true horizon is?
Yeah, it looked like a tree line in the distance. You were below the tree line.
It's not. That way is the way you look to see the Isle of Man from Southport Beach.
Well, then maybe I'm seeing the Isle of Man out there.
We were looking. Okay, well, I managed to get myself under the horizon, whatever the horizon is, whether it's topographical or whatever. But I would say it's a true horizon, the water.
You weren't in the water.
No, I wasn't.
And I didn't see any water in the picture, honestly. Where was the water?
Above my head, the horizon, the true horizon.
The true horizon, the water, the true horizon, the water was above your head. Okay.
Yeah, I surprised.
Well, you said something else too that I wanted to address, and that was you brought up elevation profiles.
Yes.
You know what an elevation profile is, Bev? It's not it's not a cross section drawing. It sort of resembles one, but that's not really what it is. The axis on that drawing is distance. The vertical axis is departure from some datum. So the baseline that you call perfectly straight certainly is on a graph, and that's all it is, a graph. That is representing mean sea level, for instance, which is curved. Every line above it is measuring above that baseline. It doesn't matter what shape line, in reality, what shape that datum is. It could be a sine wave. It could be a circle. It could be anything. 5 feet above the datum is 5 feet. It's a straight line across the page. That's what it would be. You see what that in the distance, Bill? Yeah. You telling me that's water?
Yeah.
Really?
Yeah.
You're actually going to try to tell me that that crap you're seeing that above your head is water.
Yep. The true horizon.
I don't believe
blue.
you.
I know.
Believe you, Bill.
You don't believe very much.
I don't believe you.
Yeah.
That's not water.
I know, it's amazing, isn't it? Couldn't be, could it? It's not possible. It is not possible. Impossible, isn't it, Blue?
Then that's got to be huge waves. Turn the video on and let's see the waves move around.
Okay. What do you reckon to that?
This is dependent on focal length. So you can create that effect with a greater distance if you have long enough this focal length. So, and this is no normal thing. So,
but like Blue says, it's impossible.
Yeah.
Just not possible on Blue's dogmatic model. Even though we've done it and it's in reality, it's there in the picture, you can see it.
I need paper to say focal length again.
Yes, sometimes I think I said focal point length, but this is just ridiculous because point has no length. But yes,
I more meant the fuck all part.
But focal length is I think correct.
Yeah,
it is used in photography.
Well, the one on the left is the auto level, so that's, you can see the crosshair, which is above, right? I mean, the fact that that's below, but I'm below the horizon, which is the surprising part, right? When these guys are talking about things that occur in the distance, well, do you take into account that the horizon can be above your head when you walk? Because I'm about a mile away there, away from the camera, and that is the actual true horizon, the water behind me.
Yes, for me, this is no problem because as we can see in the picture, the ground, even if we assume that this ground and this water are on the same level, which is not, but let's assume that they are pretty much on the same level. So for the sake of argument, we can say that they are pretty much planar and horizontal level. And this is what we expect to see, because that you are below horizontal, or below horizon, because you are going in the picture, this level is going up from bottom of the picture to middle of the picture. This is how we see level, going from bottom to up. Yes, like on the picture. So we see, yes, we know this is level, or more or less level, and it is in the picture going up.
And the problem is, though, right, for some people's models, right, they have the water level dropping from horizontal, right? But I'm over there in the distance. Yeah. So how can it drop from horizontal if it's above my head?
Yes, and
that's a problem, right? That's a big problem.
Yeah, for them, not for me.
Yeah, you heard Blue's reaction. He thought it was a tree line. He just said, no, that can't possibly be. You're a liar. You're mistaken.
Yes, but this is effect of ignoring perspective or optics, because when I say perspective, of course, I am talking about optics. And this is not just some poetic expression. This is very rigid let's say, science, because people are making lenses, making binoculars, making every optical devices. They, of course, they perfectly know how perspective works. They can calculate that, they can predict everything in process of production, etc. So they know everything about that. So this is not just a fairy tale that I'm talking, oh, perspective, what it is. This is how optics works. This is perspective. And this is normal that you are below because you are shrinking in distance. And because this level line is going from up, down to up, from bottom to up to the middle, and you, because you are going along this level, so in the picture you are going up, but you are shrinking. So you are small enough to be in the middle between this land and water. If you would go even farther, you will be even more below this horizon.
Yep.
And this is normal thing, which should occur in perspective. This is normal thing. This is not wizardry or magic trick or whatever.
Yeah, I would
science.
continue to get smaller, but I would eventually end up at the height that my head is.
Yeah, absolutely.
As I get smaller and smaller, that you couldn't see me, but that's where I'd be.
Yes, you would be in the water because let's say that this water would be frozen and you can walk on that water, and you will be going up to horizon
in the picture.
In the picture, absolutely, yeah.
Yeah. So I mean, for me, yeah, there's no problem because I said to these guys, I said, I bet I can get under that horizon. Now, that's not hard. You just lift the camera up and you can take a picture of you under the horizon too. But that's not what we were doing. The idea was for us to set the auto level up and walk out until we were under the horizon. It's impossible on some dogmatic globe models, but obviously in reality there's no problem. You can do it.
It is impossible for them because they are, willingly or not, they are ignoring this optics and perspective, and because they are explaining this drop from horizontal as a curvature of the Earth. So ipso facto, they are ignoring this optical phenomenon, let's say, like perspective. So when you can show this perspective phenomenon, you being below horizon, because this is an optical phenomenon, so they are stunned. They don't know what to say, because they are just thinking about their model without perspective. So when you are showing how perspective works, they cannot say anything. They cannot explain that. Okay, this is 1 a.m. here, so I'm going off to bed.
Yeah.
Good night.
Good night.
See you, paper.
Right, I'm going to do a little bit more to hear Blue's get out of how he thought it was tree lines. But, I mean, nobody's really bothered. True Horizon, Blue. We've done it many times.
Look at how uneven the top of that thing is, Bev.
The video is called Under the Horizon. Check it out on Try Thinking YouTube channel. It's when we went out for a day out.
Would you play it?
What? Would I play the video?
Play a little bit of it for me.
Okay, wait a minute. Let me set it up. Share your screen. Look at these Discords. It's good, isn't it? Watch this. Can you see that now?
Yeah, let's see. Let me go to your live.
Let me get it for the people at home. People out there. There we go. Hey, do you want to see us at the beginning?
No, I want to see that part where you're under that
There you go.
horizon.
Oh, wait a minute.
It's a giant. DP, you're just gonna have to move your leg there. Yeah.
Right. So that's us going out, so showing everybody how we do it. We set everything up, and then you want to see the end bit here, where we're walking out. Come on. Can you not?
Even your
If I get down low, I can see.
You can't see it.
If I get down low, I can see your stick. That's it.
Wow.
Music's busted.
Really?
World's famous busted.
Your measuring rod is almost underneath the crosshair.
Yeah. 5 meters.
Okay, it does look like it's
yeah,
moving around, Bill.
I can't even see you.
10.
Yeah.
I swear it looked like it
Have
looks
you
like
never
it's
been
moving,
out
yeah.
there with the camera, like a P1000? Look through it.
No.
The one on the left, the big screen there with the crosshairs, obviously, as you can see, that is an auto level.
Yeah, I would imagine that would be true.
Yeah. So as you can see within that picture, there's obviously a drop from the horizontal, but somehow the water further away seems to be higher up. Literally impossible. Well, say impossible. Definitely problematic as to how you would manage to describe that. Having the water above your head whilst having your head below the horizontal. You've got something further away in the distance being closer to the horizontal than something in the near ground. Must be tricky for anybody to deal with that sort of stuff under the horizon. Under whether the horizon does not rise to it, does it? Never has done. That's how I came into this with a conversation with a guy who's got a YouTube channel that attacks people for saying things like the horizon doesn't rise to eye level. How could it? They're horizontal planes, and horizontal planes don't intersect with each other. That'd be ridiculous to say that sort of stuff, wouldn't it? How could you have a horizontal plane rising?
You don't have a horizontal plane rising, Bev. You have a level line which is dropping away from you.
Level dropping away. And what I think I'm going to be doing is maybe cutting this video, Blue Marble and his tilting plumb bobs, tilting, sloping horizontals. He's got level dropping away in the distance, obviously. But then somehow the water not dropping away quite as much. It's a little bit further away and it's dropped less. Obviously. Easy to see that. I think when once you've been in this arena for so long, you become accustomed to it. Buster calls it, you have your rule book wrote. Somebody's wrote you the rule book that you use in order to process all of the information you're getting. And it's really difficult to process something that just doesn't make any sense. And when you look at this picture, it's hard to comprehend what it actually is showing you, because you have to then process a bit of stuff. But for most people, processing that information becomes too tricky. We call it ECV. And it happens to a lot of people. These sort of conversations, too much for people to take. I think, is he really upset? Right, I think we're going to close it down for tonight. It's been a good night. Hopefully, next time we can just deal with the arguments and stuff. I got carried away a little bit again. Let me put the Discord back on. Do you want to pick a Buster song, Rob, since you're in here?
Yeah, the one that was just playing during that thing. Fuck, what's the name of it?
I don't know. Let me listen.
It was just playing when you were showing.
At the beginning?
No, just like 5 minutes ago.
Oh, it's at the beginning of the other.
It's a song about you can do fuck
Sitting
all
on
with
the
an angle.
beach, right?
Horizons.
One chance. I've redone that new video. Yeah, I think it is. It's one chance, isn't it? Yeah, that'll do. Okay. Thank you very much. I think Ram said he's going to come round tomorrow. He said he's too busy today, so we may have a few more people in tomorrow. Please join us. It will be Free for All Friday. Just try to relive a couple of arguments. Yeah, see you tomorrow. Trying to live a couple of arguments because that's what we're on the topic of at the moment. Getting these arguments together. Nobody's really going to be interested in them within this arena, but they're not made for this arena. This bit that we're going to go into is meant for the 99.999% of people that don't have a model. People in this arena are too model afflicted. That might be you. I don't know. Might be me. But I don't want to be in this model afflicted. I've had enough. It's just boring. People talking about stuff and you're trying to get away from that topic and they just keep bringing you back and back. Okay. Join us tomorrow. I don't know what the conversations are going to be, but do what we can. As requested by Rob Keane, one chance. See you tomorrow.
Confidence in the things that I know. I have enough wisdom to see the logic will be shown. I got one chance to show you what I got. I got one chance to show I'm confident or not. Self-evident reason, deductions and conclusions, and the fools are running away. It's not what you say, it's only what you can prove. You better watch your step, you better mind your P's and Q's. You got one chance, show me what you got. You got one chance, show you confident or not. Don't get caught in a matrix of all of these fakers. Society's spinning, and I'm just here living on the ground. self-evident reason, deductions and conclusions, logically thinking, and the fools are running away. You're flipping over backwards to show me where you think you are. Your model dictates that you never see too far. Shrinking in the distance, you can do fuck all with an angle.